we are learning the data structures and algorithms in Java. So in today's topic we are learning arrays in Java. So let's get started. So normally arrays is a collection of the similar types of element which has an contiguous memory locations. So what do you mean by contiguous memory locations? So it's nothing but all the elements are located next to each other in the same memory space. That is, the consecutive blocks of the memory are allocated to the user for the processes. So there are many types of memory storage types, such as heap memories are also there. So array uses the contiguous memory location. So next point is array uses the zero based indexing, means at the element that stores at the first in the array is is stored at the zeroth index, and the next element will store at the one, then second, and this series will go on till n. N is the number of elements that you declare that the array will store. Okay. So unlike C++, we can get the length of the array using the length member. So in C++, we use the size of operator, which gives or returns us the length of the array, means the how many number of the integers stored in that array. Like that, in similar way, there is a length member in Java which returns the length of the array which we are using. So typically there are two types of arrays in Java. So first one is user defined and second one is using built-in class. So in this video typically we are going to see the user defined one, and the built-in class we can see in the next upcoming videos, wherein there is not too much work that we are going to do. We just import the class from the Java package, lang package, which is predefined in the Java, and we just make an object of that class, and we can use the predefined methods of that class. Okay, moving ahead, Java provides the feature of anonymous array, which is not available there in C++. So we will see what is anonymous arrays. So Java supports the feature of anonymous arrays. So as you don't need to declare the array while passing an array to the method. So think of a situation where you have created one method, and that method requires an array as a parameter. So when you are calling that method in the main method, so instead of declaring the new array and passing the value to that array, you can just create a new int and just pass the values that you want to pass to the array. That is known as an anonymous array, which C++ languages like that don't provide these features. Okay, so moving on, next we have the types of array. So there are typical two types of arrays: single dimensional and multi-dimensional. Okay, so let's see each of them one by one. So single dimensional array, the syntax is very similar to other programming languages. So wherein we have first declare data type like integer, and then two square brackets, an array, or we can declare this in three different ways, as you can see here. So first of all, let's write some basic code of that single dimensional array. So I'm here, and let's declare one public class main. Okay, and I will write the main method, that is public static void main string args. Okay, so first of all, let's declare and initialize one array. So for that we can do this int. That means that array is going to hold the integer types of values. Let's name our array as a. Okay, equals to new integer, and this is the 5. So this 5 is nothing but the size of the how many integer types of values that array is going to hold. Okay, so here I written 5, that means the array is going to hold the 5 values in it. Okay, so let me just go and quickly. Okay, array at index 1, it's gonna hold 20 like this. Array at index 2 gonna hold 30. Array at index 3 is going to hold 40. Likewise, array at index 4 is going to hold 40. Sorry, 50. Okay, so here you can see my array length is 5 and I have declared the 5 elements in it. So let me just print it on the console. So for the printing of a print of an array on the console, we just use a for loop, wherein our for loop will start from int I is equal to 0 and it will go until I less than a dot length. A dot length, and each time I am incrementing the value of the I. So this dot length function, you can see here, I have told you there is one method named as length of the length member, which will return the length of the array. So here we are using that same method. So quickly just I will system dot out dot println a at a. Okay, so quickly just revise it. We have declared one array and initialize, and we are given the all the values that the array gonna store at that index, and then we have used the for loop where we are traversing the array and printing the elements that are stored at the 0 to fourth element, fourth index of that array. Okay, so I'm gonna run this. Let's see. So here you can see 10, 20, 30, 40 and 50 is got printed on the console because at first i's value is 0 and array at I is stored 10, so that's got printed here, and each time the for loops runs, the value of the I got incremented. Array at 1, array at 2, array at 3 and array at 4 got printed. So this is the basic program of array. So this, so moving next, we have multi-dimensional array. So here you can see the multi-dimensional array, uh, how we can declare that array. Okay, so without wasting the time, let's code it out. Okay, so I'm gonna come here and I will comment it out this code. At next, I will again declare one array, but this time I am declaring the multi-dimensional array. That means I have to use two pair of square brackets equals to, let me just pass those value. Okay, so here I have declared one array which is multi-dimensional array, and I have passed values to it. Okay, so let us check how we can print the multi-dimensional array like we have printed here the single dimensional array. Okay, so for that we require two for loops. First one is run from I is equals to 0 to I less than 3, and each time it will iterate I plus plus. Okay, so inside this we are going to use another for loop which is going to run from I j is equal to 0, j is less than 3, and each time we are incrementing the value of the j. Okay, so in this we are going to print system dot out dot println array at index I and index j plus one space after each number got printed on the console. And after this I will just write system dot out dot println. Okay, so if I run this now, we'll see what happens. So here you can see 1, 2, 3, 2, 4, 5, 4, 5, 4, 4, 5 is got printed. So let's check how it got how it's printing actually. So when we come for the first for loop, the value of the I is 0, and when it's enter for the second for loop, the value of j is 0. And here when we enter, we pass the array as array of 0, 0, 0. So what is present at array 0, 0? This is the element which is present. So this got printed. And when we go again here in inner for loop, wherein j's value is now 1, okay, and i's value is 0. So again we are passing wherein i's value is 0, and but this time j's value is 1. So what it becomes, array of 0, 1. So at position array of 0, 1, 2 is present, so 2 is got printed. Similarly, this for loop will run one time again. When j is 3, this for loop gets terminated, inner for loop, and it go outside for loop where I plus plus is done, and i's value is now 1. Again it enters the for loop wherein j's value is 0, and this time we are going to get the values as I array of 1, 0, wherein we get these values. Similarly, we are printing all those values. So this is how we can implement the multi-dimensional arrays in Java. So there are many ways, many practical uses of this using arrays in Java. Let's suppose think about a scenario wherein you have 100 students in class, and you have to store all the data of the student. Let's suppose marks. The students got obtained the marks in mathematics, so you can't just declare one variable for each student. So in this scenario we can use an array wherein we just declare one array of mathematics marks, and we will just pass those values according to the student's roll number, and which got printed and stored, and whenever we want we can retrieve those information or the values. Let's suppose I want to know the marks or marks obtained by the students whose roll number is 8 in mathematics. So I can pass the array name and pass the parameter as 7, sorry, because the array indexing start from 0, and I will get the marks which is obtained by the student whose roll number is 8. So these are some real life scenarios wherein we are using arrays in Java. So you can go to the websites like Geeks for Geeks, where they have the practice portal wherein you can just sort those you can apply the filter of arrays, and you can set the difficulty level and do the practice for the coding. I will be sharing all the required resources and the references you will require to learn arrays in Java in the description box of the video. So thank you so much guys. I will see you in the next lecture.
Hello and welcome back to the new video of Java tutorial series. So till now we have covered arrays in Java, and for this video we will be covering some practice questions in arrays. Okay, so what is first question? Write a Java program to sum the values of an array. So input to this program is an array. So you are given an array as an input. You have to print the sum of the elements which are present inside the array. Okay, so let me open my IDE, and I will create one new Java class, name as arrays practice questions. Let me increase the font size. I'll write my main method. Okay, and now I have to declare one array which will be given as an input to the program. Int array equals to and I will assign the values to the array here itself. Let's suppose 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 8 comma 9. Okay, so this is our array, and now I will require one variable to store the sums value. Okay, now I will use enhanced for loop. I hope you guys know what is enhanced for loop. It's like a for each loop. We'll write int I in arr. What we have done here is, for every integer value inside array, we will run this loop. Okay, and what we are going to do inside this loop, sum plus is equals to I, means we'll update the sums value with the value which we are getting from inside the array. Okay, and now at the last I will just simply print the sum is, and I will concat it with the value of sum. Okay, so now if I run this, it should print the value of summation of 1 to 9. Okay, the sum is 45. Now it's working properly. So moving forward to the next question, write a Java program to print the following grid. So this is the grid that you are supposed to print on the console. It has a 1 2 3 4 5 6 7 8 9 10 10 columns, and 1 2 3 4 5 6 7 8 9 10 10 by 10 grid is this, and you're supposed to print this. Okay, and so let me get into my IDE. I will comment this out. This is the solution for the question number 1. I will comment, and I will write one more comment as solution to question number 1. Now from here onwards I will write solution to question 2, and inside this we required multi-dimensional array because matrix is there, and so I will declare one multi-dimensional array over here, integer this, and I will name my array as a, which is equals to new integer of 10 by 10, because our grid is 10 by 10 matrix. And after this I require one for loop, integer I is equals to 0 and I is less than 10. Less than 10 means the loop will run from 0 to 9, which is 10 times, and each time I will increment the value of I as I plus plus. And inside this loop again I require one more for loop to track the columns. First row will track the rows, and second for loop will track the columns. And inside this I will write intj is equals to 0 whenever my j is less than 10. I will do j plus plus. Okay, and inside this inner for loop I will be doing system.println person 2d, and I will pass it a value as array at ith index and array at jth index. Okay, so after this I will do this. Okay, now it's okay. Wait, I can simply print the value which is inside the array at I comma j index, and after printing the inner for loop I need to move to the next row, and for that I will simply write one print statement so that the program execution will get to the next line. Okay, now if I run this class, you can see 00 is getting printing on the console. One mistake is there. I have written print ln instead of I should write print, so that every time a new line should not get printed on the console. Now it's okay, fine. Yes, you can see 10 by 10 grid is printed matrix. So this is the expected output that we want to print on the console. Okay, so next question is, write a Java program to calculate the average value of the array elements. Okay, so you have given one array. You just have to print the average of the elements which are present inside the array. Okay, assuming that there are integer values which are present inside the array. Okay, so now again I will comment this solution of the question number 2, and I will write on one more comment, which is solution to question number 3. Okay, so first of all we require one array. Okay, so I will declare one array uh, of type integers, and I will name it as numbers, which whose value is equals to new integer array, and I will pass those values here itself. Let's suppose I will pass 20 comma 30 comma 35 comma minus 15, okay, comma minus 60 comma minus 100. Okay, so these are the value, just random numbers I have passed to the array, and I have to calculate the average. We have to calculate sum of the elements which are present inside the array first. Okay, so for that I will require one variable known as sum. I will assign it value as 0 initially, and after that I will require one for loop to calculate the sum of the elements which are present inside the array. Int I is equals to 0, I is less than dot numbers dot length. Numbers dot length methods will return the length of the array. Okay, and now each time I will be doing I plus plus. Okay, why am I getting error? Yeah, yes, I will return this. Okay, now it's okay. What we are supposed to do inside this is update the sums value. Okay, so previous value plus the value of the current element present inside the array. Okay, now it's okay. We have got the sum of the elements which are present inside the array. Now we just have to calculate average. So to calculate the average, I again declare one average variable of type double, and I will simply divide the sum by the numbers dot length. Okay, and now I can simply print the average of the array elements are, and now I will concat it with average. And now if I run this, I should get the average as 4. Okay, now it's okay and working fine. If you calculate the summation of 20 plus 30 plus 30 35 plus minus 16 plus 60 minus 100, and it when you divide it with the number of elements, that is 1 2 3 4 5 6, then you should get 4 as a output. That is the average of the array elements. Okay, so these are some questions. Again, I suggest you that you go to the Geeks for Geeks or any of the practice portal like HackerRank or HackerEarth. You just go there, apply the filter of arrays, and set the difficulty level to easy. Try to attempt those questions, try to solve those questions. It will help you to improve your logic building in problem solving. Okay, so thank you guys for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered the theoretical part of the array, and we have also done some uh, easy level questions of the array, and in this video we'll be talking some medium level question of the array, which requires some searching and sorting techniques. So till now I have not discussed the searching and sorting algorithms which are there in uh, for used in Java arrays. So in our upcoming videos we will cover that. Don't worry. There are a number of the sorting techniques and searching test. There are two searching techniques are there, which is linear search and binary search. We will cover that in our upcoming videos. So what will be the agenda for this video is I will be covering this three medium level questions, which are arrays questions. So I again these many questions are not enough for you to practice. You just have to get your hand dirty on the programming. So what I suggest you just go to the any of the portal, Geeks for Geeks, HackerRank, and Hacker Earth. Register there. Try solving questions on the arrays. Set the difficulty levels as easy, medium, then hard. Okay, so practice more and more so that you can improve your logic building. Okay, so let's get started. What is the question? Write a Java program to test if an array contains a specific value. So what this programs what this in this question what we have to do is we have to search for an element which is given by the first of all we require an array, and inside that array you will be getting one element which is of arrays of type arrays holding the integer values itself, and you have to search that element inside that array, whether that element is present inside that array or not. If that present inside the array, you just simply return true. It's a boolean value, and if that element doesn't present inside that array, you just simply will return false, okay, on the console. Okay, so let me get into my IDE and I will just simply comment this out. These are previous video solutions. Okay, and I will simply comment, and here I will again comment, and I will write medium question 1. Okay, medium level questions 1. Okay, now I will be creating one method inside this, and since this method is public, I will declare it as public, and I will declare it as static because I have to call this inside my main method, and which is a static method. Okay, static and this will return a boolean value, either true or false. It will return true if that element is present inside that array, and it will return false if that element is not present inside that array. Okay, and I will write my method name as contains means whether that element is inside that array or not. You can write anything whatever you want, and I will pass my array and item means the value that we have to search inside that array. Okay, and I will simply write one for loop, and I will write integer I in array. What we have to do, we have to check if the array at ith index is equals to item, is equal array at ith index, not just sorry, I have followed the traditional for loop over here. I just have to write I is equals to item. Sorry about that. And I will write inside this return true. Okay, return true. I guess this cannot return a value from a method with void result type. Why am I getting? Oh wait, I forgot that this is the separate method. Let me just remove this my main method so that program can understand this is as a separate method. Okay, now it's okay. I will import my main method over here. Why am I not getting? Wait a minute, let me check this whether, oh yeah, sorry, I have not ended the method. Now it's working fine. I will get my main method. Okay, now it's working fine. Okay, and after this for loop, when the program execution will get at line number 36, when we doesn't find any element which matches to the item that we have passed to the method. Okay, so in that case we simply return false. Okay, now it's okay, and now we will call that method inside this main method. For that, before that, I will declare one array int uh, array which is equals to I will simply assign the values over here itself, 10 comma 20 comma 23 comma 30 comma 45. You can give any value whatever you want, and after that I will require one variable item, means the value that we want to search inside that array. Let's suppose we have to search 23 inside that array. Okay, and now I will just print the call the contents method, and I will pass array and item as my parameters to it. Okay, now if I run this, since the 23 is present inside this array, the expected output should be true. Yes, it is returning true. And now if I give item value as number which is not present inside the array, then in that case I should get false. Yes, it is getting showing false. Okay, now it's working fine. So this is the solution to the question number 1. And what is the question number 2? Second question, that is fifth question. Write a Java program to find the index of an array element. So we have to find the index of an array element. Okay, so in this case we have to get one array from the user, and we want one item. Like here we have declared over here one item should be there, and we have to match whether that item is present inside that array or not. If that matches, we just have to return the index at which the item is present inside that array. Okay, this is the idea behind this question. I will comment this out and this statement also, and now here I will write one more comment, uh, medium question 2, and for this I will create one in method by the name of find index, because we have to find the index of the element that is present inside that array. And I will write public static, the return type should be int, because we are returning the index, that is the integer value. Okay, so the array method name is find index, and this method is receiving one array as an input, and integer uh, t. Let me give it as t. Okay, okay, so what we are going to do inside this, we will check one base condition. If if the array is equals to null, then return -1. This is this is called as base condition in programming. You have to check the corner cases, whether these are the cases that you need to handle, or this will improve your space and time complexity of the your algorithm, because if the array is null, means array is empty, there is no point checking, doing all those running those loops, doing all those processing tasks. Then it you can simply return -1, because if the array is null, you are not going to get that element inside that array. Okay, so this is the base condition that we have to check. And now here I will write integer length equals to array dot oops sorry array dot length, and I will require one more variable I is equals to 0, and I will declare one while loop, and inside this I will write I is less than my length. Okay, I'm doing this task. I'm running this while loop whenever my I is less than length. So initially my I's value is 0 and length value is the number of the elements which are present inside that array. Okay, it can be anything 5, 10, whatever the number of elements you pass inside that array. And inside this for loop I will check one if condition. If my array at ith index is equals to t. Okay, t is nothing but the value, the item that we want to find inside that array. In that case we will simply return the value of the I. Return the I means the this i's value. I represents the current index at which the loop is running. So if that element matches the elements that we want to pass, that we have passed to the method, then in that case return the value of the I. That means return the value of the index at which the element is present inside the array. And if it is not present inside the array, if it not matches with the elements inside that array, simply do I plus plus, means increment the value of the I, and again go for the checking whether the I is less than equals to length. And whenever my while loop is executed successfully and I still not found the element which I want to find inside that array, in that case that means that element is not present inside that array. In that case we will simply return -1. Okay, and now I hope this is the thing that we have to do inside this method. And now if I go inside my main method, I will be using the same array, and here I will give 23 as an input, the item which we are searching for inside this array. And array indexing start from 0, so 0 1 2, the expected output should be 2. Okay, and I will simply print. I will call the method find index and I will pass array and the item to this method. Okay, now if I run this, I should get 0 1 2. Yeah, we are getting 2 on the console because 0 1 2, the element is found at the index 23. And let me give the items value as 2, which is not there inside that array. In that case I should get the output as -1. Yeah, we are receiving it as -1. And if I give the array as an empty array, base condition we also check. In that case also we will receive -1. Yeah, we are receiving the -1. uh, Now it's okay. Now the one more question was there. Write a Java program to copy an array by iterating the array. Now we in this question we have given one array. We just have to copy the elements which are present inside one array and take those elements and copy those all elements inside the new array. Okay, so there are several ways by which we can write this code in optimized manner. uh, okay, so for now, till now, I'm assuming that you don't have any advanced knowledge about the arrays and problem solving. So we'll go the basic approach itself. Okay. So now I will comment it out and I will write one more comment over here stating medium question 3, and now I will comment this also. Okay. So I will write one more method over here. Okay, so what we'll be doing, we just have to copy the elements. Okay, so in that case the method should not return anything. Okay, so the return type should be void. Okay, so I will public static void. uh, wait. Do I need to create one separate method first? I think no need is there to create one separate method. We can do this kind of stuff inside the main method itself. Okay, so one array was declared already over here. I will use the same array. This items value was not required for me to in this question, and I will declare one more array I will call this as new array, new integer of, and I will give the same 1 2 3 4 5 capacity of 5 elements inside this array. Okay, and now mm, to do this, one inbuilt method was there. I will use it as okay, I will write original array, and to print this array inside one go, we have one method arrays dot to string, and we have to pass the array name to it. Okay, now it's so arrays dot to string. Arrays is the class which is provided by the Java in the util package. Here you can see, if I hover over here, you can see java dot util dot arrays, and I guess, yeah, IntelliJ IDEA has also imported the following package. Okay, what it will do, it will get array as an input, and it will convert that array into the string. Okay, so it will, here you can see it is accepting the array as a parameter, and it will convert those array elements into the string, and it will print all those in a sequence of that we have stored over here. Okay, now I just have to copy all those elements. So for the copying purpose, I required one for loop, which will start from I is equals to 0, and which will go till till my array dot length, and each time I will be doing I plus plus, and inside this array I will simply write new array. Wait. A new array at ith index means the first index, that is 0th index. I will copy the element which is present at array at ith index. Means we are just simply taking the first element of the original array, and we are assigning it to the value at the 0th index at the new array. Similarly, when we go further again checking for the for loop, at that time i's value is 1, we will simply get the first element of the original array and copy it with the first position of the new array. Okay, and after that, once the for loop is ended, the same thing we are going to do, we are going to print the copied array and we will pass new array as an input to this. Okay, now if I run this, the same array should get printed. Okay, original array is 10 20 23 30 45, and copied array is 10 20 30 23 30 and 45. So this is the solution to the question number 6th. So I hope you got some idea how these searching and sorting techniques are done in Java. There are some algorithms, like I said, linear search, binary search, and for the sorting, bubble sort, heap sort, radix sort, merge sort is there. There are so many sorting techniques. We'll also cover that all these algorithms in our upcoming video. But before that, you should go to Geeks for Geeks or HackerRank to try solving some questions, so that your logic building will get improved in the programming. Okay. Thank you guys for watching this video, and I will see you in the next one.
Hello and welcome back to the new video of the Java tutorial series. So till now we have covered arrays, data structure. So what I'll be doing is we'll be covering some hot topics, hot interview questions which are covered or frequently asked during the interview processes of the many companies. Okay, so these are the basic one that the interviewer may ask you to test your problem solving skills. Okay, so today in this video, let me just create one Java class, and I will rename it as let's suppose remove elements. Okay, so what I'll be doing is, let me just increase the font size. Okay, wait, I will increase the font size. Okay, now it's okay. Okay, so I'll just comment out the question. So what we have to do is we have to remove the even numbers from an array. So what we have to do is we have to write one function where we have to pass one array to that function, and that function will return you the new array where all the elements are odd ones. Okay, so what it does, it will remove all the even numbers from the array that you have passing to that function. Okay, so enough talking. I will give you an example. Let's suppose, okay, wait, let me just comment it out. I'm giving an example. Array, we have this array. Let's suppose we have elements, random elements, 3, comma 2, comma 4, comma 7, comma 8. Okay, so this is the array that you have passed to the function, and now the array which will be returned by our function is 3. 2 is removed because that is an even number. 4 is also got removed because that is also even number. 7 and 8 is also removed. So this is the expected output from your function. Okay, so first of all, let's break down our question. So we have to remove the even numbers from an array, right? So first of all, we need one way where we can count the total number of even integers that are present inside that array, right? So we need one way to count step. Let me just call it as steps that we need to solve. Count the number of not even, let us count odd numbers, so that, okay, after counting, step number 2 is we have to create one new array of that size of the size equals to the odd numbers present inside that array, right? So create a new array of size equals number of odd numbers, right? Now after creating the array, we just need to iterate through through the array and check whether that number is odd. If that number is odd, we just simply take that number and put it inside the new array. Okay, so I will write if number is odd, take it and put it inside new array. Okay, so these are the steps that we have to follow. Okay, so let's go and create our main function first. I will write my main function, and inside this main function I will create one array. I will be taking the hard coded values. You can also take the input from the user by taking the creating the object of the scanner class, as you know till now, I hope. Array of size, let's suppose 5, and wait, and I will pass the values. Let me give the above values itself: 3, 2, 4, 7, 8. Okay, I'm getting the error. Wait. No, now it's okay. Okay, now we have created one array, and now I will write one function call. Before that, I have to create one function over here. I will create one function. Okay, so my function doesn't return anything. It just creates or else I can return one array. Okay, for now I will not return anything. I will just simply write void my function name, or else I will return that new array itself. Okay. You can also write void, but one extra thing that you have to do is you have to print that new array inside that function. Okay, that part we have to do extra. Over here, I'm not doing that thing. I will write remove even, and I will just pass the array to it. Okay. Now inside this function, first thing we have to do, we have to count the odd number. Okay, so for counting part I need one counter variable. Let me just call it as odd count is equals to 0, initially 0, and we need one for loop. So this for loop will iterate from I is equal to 0 to I till less than array dot length, and each time we will do I plus plus, and inside this array we'll check for if condition. If array at current I index is mod 2 is not equals to 0. Okay, so what this line will do is it will check that number, and it will check if it is divisible by 2. Mod 2 means if it is divisible by 2. If it is divisible by 2, that means that number is even number, and we will not count that number as an odd number, and we will not increment the value of the odd count. Okay, and inside this we will simply increment the uh, odd count by 1, odd count plus plus. Okay, so first step is done. Now we have to create one new array of size the number of the odd numbers present inside that array. Okay, so I will write int array. This is the result array, so I will name it as result new int of size odd count. Okay, okay. Now inside this I will again need one uh, variable to get to take the track of the indexes of the new what we can say new array. Now inside our for loop I will just write int I is equals to 0, and this for loop will again run from int I less than array dot length, and each time we will do I plus plus, and here we are checking one condition. If array at ith index mod 2 not equals to 0. Again, if that number is not equals to 0, what that means, that number is an odd number, and we have to push that number inside our new result array, and I will pass as index, because indexing of this resultant array will be different as that of the our array that we have passed to the function. Okay, and we'll write array add I. Okay. After passing that, we have to increment the index index variable also, so that next time the I index will be switched to the next part. Okay, for suppose for the first time index value is idx value is 0, so it will push that variable sorry number to the 0th index, and next time idx plus plus will do the 0 to 1, and next time when we are pushing that number to the array, it will become 1. Okay, now at last I will just simply return our resultant array. Okay, and over here I will call that remove, I will call that function over here. Let me just call it, wait, okay, why am I not able to call this? Wait a minute, guys. Int remove even, remove, and I will pass array to it. Okay. What I am getting a non-static method. Oh wait, now I have to switch it as static because, as we know, non-static methods cannot be called inside the static method. So our main method is static one. That's why we have to create our new method as a static one also. Okay. And now this whole thing I write inside a print statement. Print remove even, and I will pass our array to it. Okay. So that is pretty much I think we have to do. Let's hope. Okay, so this is getting run. Build is going on. Build is complete. Okay, this is returning, I guess, object. Wait. This thing we have to do, I think. Wait, let me just comment it out, and I will just simply, what we can do is create one array, int array2, and we will assign it as a, and I will just simply write sort of AR2. I hope now this will work. Wait, guys. This is printing the objects. I don't know why. Wait, let me check once. Okay, guys. I think by this we are storing that array inside our this array ARR2. But one thing is, it is doing that it is printing the object. So I guess instead of printing this, we need to iterate over that array. Okay, so we have to run a for loop over here. I is equal to 0, I is less than arr 2 dot length, and each time we'll be doing I plus plus. Okay, and inside this we'll just simply write not print ln, only print, because it will print all that array inside the vertical manner. Okay, now I have to just print array of 2 at ith index. Yes. Okay, so now it will print the new array which is returned by our function. So expected output should be 3 and 7 inside the new array. Let's see. Yeah, 3 and 7 is getting printed. Only thing is that I just have to print one extra line over here. I will just simply write over here itself. Okay, now it's okay. If I run again, 3, 1 space and 7 should be printed on the console. Yeah, it is getting printed on the console. So quick summarize what we have done in this question. We have removed the even numbers from an array. So let's suppose this is an array. It will remove the even numbers from an array. So one thing, let me clear. The way I do in is not the only way you can do it. You can also try in the new ways. Right now here we have created one new array, and we are storing that number inside this array. We can solve this, by using one array itself, but only thing is optimization should be there. Okay, so that part comes under the time and space complexity, so we will also cover those lectures in our upcoming videos, how to reduce your space and time complexity of your code, which will improve the code by much way. Okay, so here, that's all for this question. I will see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So today in this video we will be covering another question which is frequently asked in our interview process of any companies. So the question is how to reverse an array in Java. Okay, so let me just create a Java class and name it as reverse array. Okay, so let me just increase the font size. Okay, now it's okay, I guess. Okay, so let me just give my one comment, which is question reverse and array. Uh, for example, the original array that we have given is, let me just write original array. Original array is, let's suppose 1 comma 2 comma 3 comma 4 comma 5. All right, and the array 1 that we have to return is the output. Let me show it. 5 comma 4 comma 3 comma 2 comma 1. Okay, so this is the array that we have to return. Okay, so let's go and write this met function. Okay, so we have to write this function, so we just have to reverse an array, so I don't think we have to return anything. So let me just write as method name as public static void as return type, because we do not return anything to after this function. And I have to pass the array. Okay, the array, let me call it as numbers because it's an integer array, and we have to pass start index and we have to pass the end index of that array. Okay, so this is a question, this is the method declaration. Why we have written static? Because we are calling this method inside a main method, and main method is a static one. That's we have written static as the method type. Okay, and we need one while loop. Okay, so inside this while loop, one thing we can do is we can achieve this using single array itself. Means what is the meaning? We just modify the array which will be passed to this function or the method. This method is accepting one array, right? So we will do such things that we will modify this array and reverse the elements and store those elements inside this array itself. Okay, and another way in doing this is you can create a new array, and you can create a new array and you can traverse this original array in the backward manner, and you can just go on taking those elements and adding those elements inside the new array. But one thing is the drawback of this approach is you have to create one new array, right? It will increase the space and time complexity of your code itself, right there. So what we will be doing is we will modify things in such a manner that we will be requiring one array and we will do all those modifications inside this array itself. Okay, so while I will write one while loop while our start is less than n. Okay, so this loop will run until our start integer value is less than end integer value. Okay, so what we'll be doing is we'll be write one temp variable, and I will assign the value to it as integer of start. Okay, and over here numbers start is equals to numbers end. Okay, and over here I will write numbers of end is equals to temp, and after that start plus plus and minus minus. Okay, so let me explain what we have done down here. We are just swapping those numbers. Okay, so what swapping means, we are taking one element from that array itself, and we are swapping that element with the other element inside that array. Okay, so initially what will be the starts value? Initially the start value is 0 because the array indexing start from 0. Okay, and what is the end value? End value is the length of that array minus 1, because since the array's indexing start from 0, that's why we have to minus 1 number from the array's length. Okay, and over here we have assigned the numbers of start, means numbers of zeroth element, that is 1 to the 10. So initially 10th value is 1, and numbers of start we have assigned to the numbers of end. Numbers of start is this position, first position of that array, and we are assigning or changing the value of this position as numbers of end. Numbers of end is 5. So after the first after running the ninth number, the number which is stored at the first index of the array is 5, and numbers of end is equal to 10. Numbers of 10 means end position will be stored the 10th value. What is the 10th value? 10th value is the first element of the array. Okay, so after this, after line number 10, the first and last number got successfully swapped. Okay, and we will just simply increment the value of start. Now the for the next iteration, the start value will be at over here, and the end value will be at over here. So these numbers will also get swapped and will be at 4 comma 2. Okay, and when we are at 3, the start value is also 3, and end pointer is also pointing at 3. Okay, so at that time this 3 will not get swapped, since this is the middle point of that array, and after this iteration we'll break this condition, because start value will be over here, and end will be end value will be over here, and this start value is no more less than the end value, which is exceeds, and this while loop will break, and after that our whole array will get reversed at this point. Okay, so I will write main function, and I will create one array which is equals to the, let me give that example array itself over here, 1 comma 2 comma 3 comma 4 comma 5, and I will just call that method. Okay, reverse, and I will pass our array, comma, start index should be 0 as we know, and end index is the length of the array. That means arr dot length, and since the array indexing start from the 0, we have to minus 1, because array dot length, this will return the arrays in length as 0 1 2 3 4 5, but the indexing should there for the till 4 number. And now after this okay, so we have to print that array again. For that we will iterate through and for loop. I will write I is less than arr dot length I plus plus, and inside this for loop we will just simply print array at height index plus. Okay, so this is the thing that we have to do inside this question, I guess. So let me just run this. Okay, so you can see 5 4 3 2 1 is getting printed, which is exactly the reverse manner of this 1 2 3 4 5. Okay, so you can give as much value you want over here to the array, and you rerun this code, you will get the exactly the opposite in the reverse way of that array. And you can also take the input from the user from here. You just simply need to create this object of the scanner class and take the input from the user and pass that array to this function over here. Okay, so try doing giving some more inputs to this function, and I hope you got this question. Thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered two questions which are frequently asked in the interview processes, and now today we will be covering another question, which is to find the minimum or the maximum value inside an array. So what they have done over here is you will be given an array, and you just have to find minimum or the maximum value from the array. Array will consist of the integer numbers, and you have to find the minimum number from that array. Okay, so let me just write question over here. Find maximum from an array, and let me give an example. 5 comma 6 comma 9 comma 10 comma 25. So let's suppose this is an example. So after giving this array to our function that we are going to write, the expected answer should be 5, because among those 5 integers 5 is the minimum number, or else if you're finding the maximum numbers, the result should be 25. You can do anything. You can find minimum as well as the maximum. Okay, so in this question we will be finding the minimum. You can try for the maximum one. If you get some error, you can do comment out. I will be giving you the reply. Okay, so I guess we have to find the minimum value. For that we have to return that minimum value inside in the integer format. Okay, so the return value of the return type of the our method should be integer. Okay, and our method should be static because we are calling it from the main method of type int. I will name this method as find minimum. Okay, so to this we will be writing array, because we need to pass that array to that function. Okay, so inside here I will be need one integer variable which will store the value of the minimum number from that array. So initially I will be doing array at 0 as the minimum number. Initially I just assigning the 0th index integer value to the minimum variable over here. Okay, and now we need one for loop which will iterate through the entire array that we have passed. I is less than array dot length, and each time we'll be doing I plus plus. Okay, so we need one if condition over here. Array at I is less than min. Okay, so if that's the case, we just need to update the value of the min variable. Okay, so what we are doing over is array at I. So let me give you an example. If it is the case that array is iterating for the first time, so let's suppose this is the array, and array at I index, that is 0th index, is 5. So this is the element. We are assigned it to the means value. So let's suppose means the mean value is 5, and if condition we are checking array at I, that is 5 is less than 5. So this will be evaluated as false. So loop breaks and will come out of the loop, and for the second time I's value is 1. So array at I means array at 1. Array at 1 is 6. Is 6 less than 5? No, this is not the case. We will again, if condition is evaluated as false, again we increment the value of I, and again we will check whether array at 2. Array at 2 means 9. 9 is less than min. Min is value is 5. Again it will evaluate as false. So in our case it will never evaluate as 2 until and unless there is a number inside an array which is less than 5. If that number is less than 5, it will just simply update the value of the mean to the minimum value, means that iteration value. Okay. And after this successful running of the for loop, we will just simply return the mean value. You can also find the maximum value in the same manner. You just try once finding. I will just write int array, and again you can provide your own input also. Nope, no issues. 5 comma 6 comma 9 comma 10 comma 25 comma 4. Okay, and I will just call find minimum. I will write our array over here, and I will just do this entire thing inside this print statement, so that the value that the function is returning, that is the minimum number, should get printed on the console over itself. Okay, so if I run this, 4 should get printed. Yeah, 4 is getting printed on the console. Let me just modify one condition. Now 5 should get printed. Yeah, so let me just try with the negative number. Let's suppose negative 9. So what do you think, what will be printed? Yeah, you guess right. Minus 9 is getting printed on the console. So this is pretty much about finding the minimum number inside an array. You can do some modification inside this code to get the maximum number. Try building your logic, because by watching these kind of videos, just watching the problem solving videos will not help you improving your problem solving skills. You have to practice a lot. Try solving the Geek for Geeks portals problems, or Hacker Rank, Hacker Earth. There are so many portals out there. Try solving those questions, and so that you can build your problem solving logic. Okay, so thank you for watching this video, and I'll see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So today in this video we'll be solving another problem of array. So that is the finding the second maximum value inside an array. So in our last video we have covered finding the minimum or maximum value inside an array. So in this video we will be covering another question which is asked many times during the interview process, that is finding the second maximum value inside array. Okay, so let me just create one a class called second max, and I will let the question. So what we have to do is find second max value in array. Okay, so I will give you one example. Let's suppose 1, 2, 5, 9, 7. This is the array. So what is the expected output should be? So the highest value is 9, and after 9 highest value is 7. So the output of this array should be 7. So this is the thing that we have to do. So for this we will write one function, and that function will be returning the second maximum number inside an array. So the return type should be of type int. So let me just create one public static method of return type int, and I will name it as find second max. You can also try finding the second minimum number from this array. So try solving it. You just have to simply change some conditions so that you can get the minimum number, which is second minimum number from the array. Okay, so here I need one variable to take the track of the largest element inside that array. Okay, so integer dot mean value. Okay, so don't worry, you will be asking what is this mean value represent. Okay, so here you can see, if you hover over here, Java has some predefined values inside the language, and these are nothing but the constant. Okay, so which are defined by the Java itself. If you write integer dot mean value, some value is assigned to it, that is -21474836448. So this is the values assigned by the Java. You can use it inside your code. You can also write max value, as other constants are also defined inside the Java. So if you want some overview of this, you can just go over here and write uh, Java constants, and if you go over here you can find this article which gives you pretty much idea about the Java constants. Okay, and now moving to our question, I need again one more counter variable which takes, not the counter variable, a variable which tracks the value of the second largest element uh, inside the array. So integer dot mean value, and now I will require one for loop which will iterate through entire array. Again the length should be arr dot length, and each time we'll be doing I plus plus. Inside this we'll write one if condition, that is array of I, if it has max, then I will just simply write second max, assign the second max value as max value. Okay, and I will just simply update the max value as arr of I. Don't worry, we'll do one dry run test to check what is going on inside this uh, code. Okay, so don't worry, be with me. Array of I is less than second max, and we will require one more and. So I hope you remember this. What is and, what is or. And means both the conditions should be evaluated as true. Until and unless both conditions are evaluated as true, loop, the program control will not enter inside this else if loop. Once when all these both the conditions are evaluated as true, then and then only the program control, the execution flow of that code should enter the inside this else if loop. Okay, so array at I is not equals to the max. So what if that's the case? Inside this we will be doing second max is equals to arr of I. Okay, so this is the thing that we have to do inside this for loop, and after execution of the for loop we will just simply return the variable second max. Okay, and now inside our main method we will just create one new array, and we will pass those values as we have taken inside the example 5,9,7. Okay, and now I will call that method that is find second max and pass our array. Okay, so first let me run this and check whether we are getting the correct yeah, 7 is getting printed on the console, which is the second maximum number inside that array. And let me once check by changing some values as 8. Now this time 8 should be print on console. Yeah, it is getting printed on the console. So wait, let me just put one debug pointer over here and try to debug this code. so that you guys can understand this easily. Okay. Okay, so let's now when the program is execution at line number 23, this array here you can see 1 2 5 9 7 8 is passed to this find method. Okay. The exam the program execution flow comes to this method call. Okay, and now so here you can see max has the value assigned as this value we have seen, the predefined value which is assigned by the Java to this min value constant. Okay, so second max is also assigned that value. So for the first iteration i's value is 0, here you can see, and if when that if condition is checked, the max value is this and i's value is 0, here you can see. And let's go ahead. Okay, so for the first time, so array of I is all obviously greater than max because this is the value that we have assigned minimum value. Okay, so next second max has assigned the value this. Okay, now again we'll check for I is equals to 1, here you can see I becomes 1. And now this time we'll check array at 1 is 2, whether 2 is greater than a max value, that is 1. Yeah, obviously we will get inside this loop, we'll update the second max value as 1, which is the previous value, and we'll update the max value as 2. Here you can see max value is updated as 2 and second max value is updated as 1. We'll come here, we will check this, and again we will check, we will come here, we will assign the second max value as 2, and I will update the second max value as 5 because till now the maximum value is 5 inside the array. Here you can see we have updated the max value as 5 and second max value as 2. And again we will run this loop for I is equal to 3. So what is the value element as I is equal to 3, 0 1 2 3, 0 1 2 3 9, whether the 9 is greater than 5, yes it is. We'll come inside this loop, we will assign the value of second max as 5 and we'll update the max value as 9. So after successful completion of the I value is 3, our max value is 9 and second max value is 5. Okay, so for now I is equal to 4, I is equal to 4 is 0 1 2 3 4 7. 7 is greater than 9, no, we'll break that if condition, we'll come inside the else if condition, and now inside this else if condition, once we check this else if condition will be evaluated as true and max value is 9, and now we'll update the second max value as 7. Okay, 7 itself. Okay, now again we will run this loop, we'll do these steps, and at last we will get 8 as the second largest number inside that array, which is true. Here you can see 1 2 5 9 7 8. 8 is the second largest element inside that array. Okay, so which is returned to this return statement over here, and after that return statement we will come here at line number 23 where we have left to that program's call, and here we can print that number on the console, and exam process successfully and it is printed on the console. Okay, so this is how this program works. I hope you got this question. Try solving and finding the second minimum number inside that array. Okay, so for this video this is pretty much. Thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So today again we will be solving another question which is frequently asked in the interview processes, and the question is how to move zeros to the end of the array. Okay, so let me just create one new Java class. Wait. Java class, and I will call it as move zeros. Okay, so let me just comment it out our question. Move zeros to the end of the array. So this is our question. So let's suppose we have given array as 6 comma 5 comma 0 comma 8. So at the resultant array should look like it's 6 comma 5 comma 8 comma 0. So this is the resultant array. We have shifted all the zeros which are there inside this array, original array, to the end of the array. Okay, so this is pretty much we have to do. And so since we are doing all these operation inside that array itself, I don't think so we have to return anything after that function call. So I will, for time being, I will call it as static void, not void, sorry, void. I will name this method as move zeros, and I will pass array and one integer. Okay, so inside this I will assign it as int j is equal to 0, and I will call it a run one for loop. So our for loop will run from I is equal to 0 to I till n. N is the side of the array which is passing over from the method call. Okay, and now inside this I will check for one if condition. If my array at ith is not equals to 0, and condition should be there, which states that both the conditions should be evaluated as true, until then and then only we will get inside this if condition. Okay, and array at j equals to 0. And inside this if condition we will simply write one temp variable which has value as array of I, and what we are doing here is just swapping those two numbers. Okay, if we found 0 at that in particular index, we will swap that value with the value which is at the end of that array. Okay, so we'll assign array of i's value to array of j's value, that's the last value, and after that we will just simply assign array of j's value to the 10th value. Okay, so here we are doing swapping, and again we will check one if condition. If array at j is not equals to 0, if that is the case, we will just simply increment the value of j over here. Okay, so I think this is pretty much that we have to insert this method. Let me just call my main method, and I will write int array, and we'll pass the same array that we have taken example 6 comma 5 comma 0 comma 8. Okay, and now from here we will write not, since our method is returning nothing, what we can do is we can call that method, and after calling that method we will just simply print that array. Okay, because we are doing modification inside the same array, that's why we can print that array after the method call. Okay, why am I getting the error? Oh, okay, so I have to write the n value also. N value is 4. Okay, and now if I Just wait, not like this. I have to write one for loop to iterate over that array. I is equals to 0, I is less than array dot length, and each time we'll be doing I plus plus. Okay, and inside this for loop, you just simply print array at I by one extra space and not ln, because we want the array should be printed in the one line itself. Okay, and now if I run this code, the expected output should be 6580. Yeah, 6580 is getting printed on the console. Let me just modify and try to give some more zeros inside this code. Okay, 06 comma 0 comma 5. Okay, so let me run this. So all those three zeros should be shifted on the right hand side of this. Okay, now again, let me try to give some more input to this code. Okay, now if I run this, those zeros should be get shifted. Okay, so we have one issue. Our zeros are not getting shifted. Okay, so let me just try to figure out what I have done mistake over here. Okay, wait, I will just debug this code and try to solve that error, rectify that error. Okay, wait. Let me just check. I will check this code. Okay, so I think this might be the error. Instead of hardcode values, I will just write array.length. I don't think so that is the error, but let me check if it is. Yeah, that's the error inside our code. Array.length that we have to pass. Now you can see all the zeros are shifted at the end of the array, and all the integer are first comes integer, and all those zeros integers are come after that. Okay, so this is pretty much about this question. You can try by your own, try solving it, and this will improve your logic building skills also. Okay, so I will see you in the next one. Thank you. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered a lot of questions using arrays. Okay, and now I guess this is the last question that we are doing on array. So after this we'll be starting our new concept, that is strings in Java. So string is has some vast concept in Java. We'll see that in our next videos. For this video, we are covering one question which is frequently asked in Java: how to resize an array. Okay, so we want to resize an array. So for this, I will just create a new Java class, resize array, and inside this Java class, I will first of all write our question that we want to perform. That is how to resize the array. Let's suppose we have array 1, 2, 3, 4, 5, and we want to now till now the array size is of 1, 2, 3, 4, 5, contain 5 elements, and now we want to resize this array as 10 array which is holding 10 elements. Okay, so we want to resize the array size as 10 elements. Okay, wait. Okay, nice. So this is our goal that we want to achieve. elements. Yeah, it's okay. So first of all, we'll write one function to achieve this thing. Okay, and I guess we have to just resize the array, so we are not returning anything. So for time being, I will just write public static void as return temperature, because function doesn't return anything, I guess, for now. And resize is the function name, and it will accept two parameters, that is one array that we want to resize, and the new capacity of that array. Okay. So okay, and now what I will do is I will create one new array, name temp new int of capacity. So what is capacity? Capacity is the capacity of the new array that we want to create. Okay, and now I will create one. Oh, wait. And now I will create one for loop, and in this for loop, we will run till I is equals to 0 and I is less than our array dot length. And each time we will increment the value of I by 1, I plus plus. Alright, and inside this I will just simply assign temp at ith index value to array at ith index. Right, so we are just assigning the values of let's suppose for the first time where the i's value is 0, we are simply assigning the array at zero's position value to the temp at zero's position. Alright, right. So this for loop will run until the size whole arr array, and after that it will break the for loop, and after that we just simply assign the value of arr to 10. Yeah, now instead of pointing that original array arr, now it is pointing to the new array temp. Alright, and now if we write the main function, and here I will just simply create one new array named arr, and I will assign those values. Let me give the values upper itself 1 comma 2 comma 3 comma 4 comma 5, and after that we'll just simply call that function resize, and I will pass our array, and I will pass the new capacity as array dot length dot into 2, because array dot length is gives 5 and into 2 is 10. So that's the thing that we want to achieve. Alright, and after that I will just simply print my entire array. I is equal to 0, I less than arr dot length. Each time I will be doing I plus plus, and I will simply print array at I plus 1 space. Alright, so what we have done, quick recap. We have created one function named as resize, and which is accepting two parameters. One is array and one is capacity, which is a new capacity of the new array that we are going to make. Okay, and so here we are making a new array of capacity that is given by the user as the function, and after that we have created one for loop where we are simply assigning the values of original array to the new array, and after that we will just simply assigning the value of the array to the temp, that is a newly created array. Okay, and here we are just calling that function, and after that using this for loop we are just printing the entire new array. Okay, so let me run this. Okay, it means good. Yeah, so here you can see 1 2 3 4 5 is also printing over here, and one thing we can do is we just simply print the arr dot length. This will also give us one idea what exactly been happen, whether the array size is increased or not. Okay. Wait a minute, wait a minute. Right here you can see the array size is of 5. You can see over here. Alright, this is how you can resize the array in Java. So thank you guys for watching this video, and I'll see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered arrays. We have done a lot of questions on arrays. We have practiced some of the questions which are frequently asked during the interview process, and I guess this is pretty much idea or the foundation you want to learn arrays. And what you can do is just pause at this moment, just pause this series for some 1 to 2 days and go and practice on more and more questions on hacker rank or geeks for geeks, or whatever code platform you prefer. Lead code is also there, and try solving those questions using the array tag. And you can also set the difficulties as easy, medium, high, or difficult, whatever you want. But at least try. This will improve your logic building skills. Okay, so if you have done that part, so you can continue this way. And in this video, we will be covering strings in Java. Okay, so let me just create one new Java class named as string. Let me just call it as string Java. String Java. Okay, and I will just simply write my main method. Okay, now it's okay. So what is string in Java? In Java, string is basically an object that represents a sequence of character values. An array of characters works same as the Java string. What I tell is here is, you just keep attention over here. Let me just give you an example. If I create one array of type characters, and let me name it as ch, and I will just write over here, and I will assign the values to that array as random a, comma b, comma c, comma d. Wait. Mistake. C, comma D. Now it's okay. So if I create this array, and instead of this I will just write string s is equals to new string, and I will pass it as ch. So here what I have done is I have created an array of type characters, and I've stored those characters a, b, c, d inside that array, and I have passed this array to the string s. Okay, so at line number 4, what it does as, it will get that a, b, c, d character as a one single string, and it will treat it as a, b, c, d. Now, this is get stored inside the memory. Okay, so it is as same as this is another approach I'm telling you. You simply go and write string s is equal to, and simply assign a string a, b, c, d. So instead of writing these two lines, you can still achieve the same output a, b, c, d as here. So I'm getting error, I have written s over there. Yeah, you can achieve this also. Okay. And now Java string class. So string, one thing you remember, for other programming language like C++, you write string as a s small, or in Java you write the string with starting s with capitalize. And you, as of now, you should know that everything in Java you write with capital letter, starts with capital letter, is a class in Java. So Java provides, so string is a class in Java. Here you can see the implementation part. If you hover over this icon, and public final class string, which is implementing this many classes. Now okay, so you can go through this official documentation of Java to see how the strings works in Java. So Java string class provides also a lot of methods to perform operation on the string, such as compare, concat, equal, split, length, replace, compare to, intern, substring. We will be covering some of the frequently used functions in string in our upcoming videos. So for till now, you just remember string is a class in Java which has some different methods, which has different methods to implement it. Okay, and now we'll just go through this concept of string. Okay, now what is how to create a string object. So now you have understood what is string. So how to create a string object, let's see. So there are two ways. First one way is by string literal, and one more way is by using by new keyword. Okay, so we'll discuss now these 2 points. Okay, how to create object of the string. Okay, so by string literal is Java string literal is created by using double quotes. For example, let me just write string s2 is equals to anything string welcome to the series. So this is the one way by which you can create a string, which this is the way of by string literal. Okay, and now by using the new keyword you can also create this string. So how we can create, let me just give an example. String on this time s3 is equals to, you just have to write new string and you just pass the same string here that you have written, or anything that you want to assign value to that string variable over there. Okay, so this is the way, two way by which you can create the strings in Java. Okay, so one more concept is there. Now one thing you tell me what you can interpret. Just pause the video and think about it. String s4, and I will write it as welcome. Okay, and I will create one more string by the name of s5, and I will write the same string, exactly the same string, where the W is capitalized and all the letters are small case. Okay, so what do you think? Here the Java memory allocation will allocate the S4 and S5 the different memory instances or not. So in this case in Java, whenever we create S4 and S5 which has the same exactly value of strings, it doesn't create a new instance. What exactly the Java do is, you can understand by this example. Okay, so here you can see S1 and S2 has the same value of welcome. So Java has a string constant pool where inside the heap memory, this pool is there where Java stores all those values of the strings, and whenever you create a new string, it will check through entire string constant pool. If there is a string present which has the same value that you have assigned previously, it will just point that variable to this string in the string pool, which is inside the heap memory. Okay, so this is one thing that I want to tell you. And there are several methods are also there, which is there inside the string class. Let me just give you one example. Okay, let me just give you one example. What I can do is, okay, so look at it. I will just come here and I will create, not I will create, I will just use these S4 and S5 itself. Okay, let me just write one more thing is add the, I will come add the. Okay, and now if I simply system.out.println, and I will write string s4 length is, and I will concat this string with the method s4 dot length. So this will return the number of characters inside this string. That means the string length, how many characters are present inside that string. Okay, and now if I run this, you can see the string f4 length is 7. Why 7? You can count here. Okay, 1 2 3 4 5 6 and 7. Okay, 7 characters are there, that's why 7 is a string. So similarly you can perform this same method or operation on this s5 also. You just have to write s5 dot length. Oh wait, one mistake, you just rectify over here, s5 should be there because we are printing the length of the s5. Okay, and now if you come here, string s5 is 14. Why so? Because you can count 1 2 3 4 5 6 7 8 9 10 11 12 13 14. This method will also count the blank spaces which are given over here after welcome and after at. This will also treated as a character in Java. Okay, while calculating the length. So these are some methods, and one more method is there, which is, wait, let me just get it over here. And yes, one more method is there, to lowercase. So this is the method, and similarly there is one more method is there, to uppercase, which also converts all those letters inside the string to the lowercase. And if you use the to uppercase, it will also convert that all the characters of that string to the uppercase. Okay, so to achieve this, you just simply write s4 dot to lowercase. And now if I run this, let me just comment it out so that you can see only one output on the console. Yeah, you can see welcome is printed, but initially we have given w as a capital, and whenever we apply that to lowercase method on the s4 string, it was giving the output as w small, because to lowercase will convert all those characters inside that string to the lowercase. And similarly you can achieve one more to uppercase. You can see to uppercase. Now what you can think, yeah, all the characters inside that string are converted to the uppercase format. Okay, so these are some uh, methods which are there inside the string. What you can do is you can simply and come here and write string in Java, and one first page Java string, which is of Java T-Point website. You just come here, go through it, whatever I told you is there itself. You can come here and read it, and here you can see Java string class methods. You got these huge list of 28 methods which is implemented inside the string class. You can come here, you can also check the official documentation of the this Java string intern method. So you can come here and also see some example of this, try those examples, look at those methods, and that's all for this Java string. And in our upcoming videos we will be covering some, again after again what we do after creating this theory, clearing this theory part, we will move on to the coding questions. We will try solving some coding questions using the Java string. Okay, so thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered arrays and string in Java. So from this video onwards we are starting linked list in Java. Okay, so linked list is easy and more my favorite data structures. Okay, and I also love you implementing the linked list in Java, and you also love it, I'm sure. And so let's go. So single linked list is a data structure used for storing the collection of nodes which has the following properties. Okay, so till now we have seen arrays. Okay, so let me show you one thing. Here you can see, so this is one. I hope you guys can understand by this. So till now, you have seen one array like this. Okay, array. So this is the array which has elements 1, 2, 3, 4, 3 and 3, 6 elements which it is storing. And now what linked list does is, linked list does exactly the same way. It stores the data but in the format of nodes. Okay, so these nodes have some properties. Okay, so let me just give you an example of the node itself over here. Okay, so here you can see, so in Java linked list, this is the one node. Okay, so let me just write one node over here. This is one node. Okay, so this is one node which has two parts. One is data part and one is next part. So this is simply represents one node in Java. Okay, and which is pointing. Okay, so this is and which is pointing to null. Okay, so this entire thing in it's one node in Java which has some characteristics. Okay, or properties. It contains sequence of the nodes. Okay, in the singly linked list, you can see these when these multiple nodes are connected in a chain. Okay, and these are connected with one another. Okay, and a node has data and a reference to the next node in a list. Okay, so it has two sections. One is data section and the next section. Data section will hold the actual data or the value with that node going to hold, and next in the next part it contains the address of the next node that is it is pointing. Okay, so let's suppose so like this we have multiple nodes. Okay, let me just give you an example. Let me just get it over here. And for example, these are the two things. Okay, these are the two nodes in the two nodes. Okay, one node, and here in the next part it is has the address of these node. Okay, so this node and this node is connected using the next part here, the address which is stored here. Okay, now the first node is the head node. Always remember, the first node of the linked list is called as head. Let me just write it over, head. And the last node is of the linked list, it's always pointing to the null. So if you consider these type of nodes, let's suppose there are five elements in the five nodes in the linked list, and after the fifth node's next should point to the null, which represents that this linked list ends here. And in some of the reference books you will also find as the last element or the last node of the linked list is called as tail. Okay, so the first node is called as head, last node is called as tail linked list. Okay, so in Java or in general there are three types of linked list. Okay, one is singly linked list, second one is doubly linked list, and third one is circular linked list. So we are going to cover all these linked list in detail. So starting with the singly linked list in this video, in this video I will just give you one overview of the singly linked list, what exactly it is. So you understand, the in linked list the data is stored in the format of node, and node contains the two part, that is data and next part. Data parts holds the actual value, and next part holds the address of the next node to which it is pointing, so that it just goes in the chain format. And always remember, first node of the linked list called as head, and the last node of the linked list called as tail, and the last node's next should point to the null, which is representing that this linked list ends there. Okay, so this is the idea of the singly linked list. I hope you got some overview of the linked list, how linked list works in Java, and from next video onwards we'll be starting all those operations like insert operation, how to print the linked list, how to delete a element, and how to uh, get the element or fetch the element, how to check whether the element is present inside the linked list. All these queries we will solve using the linked list in our upcoming videos. So stay tuned, and thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So in our previous video we have seen the theoretical concept of the single linked list. Okay, so now from this video onwards we have starting implementing all those functionalities of the single linked list that we want to know in order to understand the single linked list. So first of all, in this video we'll be covering how to make the list in the using a single linked list. Okay, so let me just come here and create a new Java class, and I will just name it as singly linked list. Yes, now it's okay. So before that, I hope you have watched our previous video where we have discussed the theoretical parts of the single linked list, and in that video I have told you that we need one node to make a single linked list. Okay, and that node contains the two parts. One is a data part, and one is next, which holding the address of the next node in the list. Okay, so for that, let me just come here and I will create another class which is our node of the linked list. I will name it as node S, which is node of single linked list. Okay, node S, and here we will create that structure. I hope you guys remember that structure. Let me just recall if you don't know what I'm telling. So this structure I'm talking about, this structure we are trying to create inside this class. Okay, so this class. Okay, so let me just come here, and we know we want two parts. One is data part, I will name it as data, and another one is next, which is holding the address. So since it is holding the address for the next node, so the type of these variable should be node s, and I will just write this variable name as next. Okay, and now one thing, whenever this node is getting created, we want these that values that the user is given should assign to these two variables. Okay, so for that we need one constructor over here, and I will write one constructor of node s, and this constructor will accept one parameter, that is data, which is given as an input by the user, like what's the data that the node is going to hold. Okay, so and we will assign these dot data, which is equal to data, and these represent to the current instance of the variable, and then our next should point to the null. That is the simplest idea of the node. We have taken those two variables and we have assigned that value, and according to the node, this is the idea, that is the data part is over here and next part is over, and this next is pointing to the null. We can change that null if there are more number of nodes inside the linked list. Okay, so for now I guess this is the pretty much that we have to do inside the node. And now if I go inside my main class, which is over here, and I will just create one function to make a list. Okay, so to create a single linked list. Okay, and now since we are accepting your input from the user, we need our scanner class to be imported. So I will write import java dot util dot scanner. So we have imported the scanner class, and now since we are going to make multiple functions, I guess it is good to declare the scanner object globally inside the classroom. Okay, so I will write public static scanner sc is equals to new scanner system.in. Okay, so now we have created this, and now I have told you one more thing. The first node of the list is called as head, and the last node is called as tail. Okay, so we need those two variables also. So we write public static. So these are node type, right? So we write public static of type node s. One is head, and one more is tail. Alright, now I think we are good to go to write the function. So I will just comment it out as function to make the singly linked list. Okay, so inside this I will write my function public static and node s, and I will name my function as make list. Okay, so here you can see public static, and node s is the return type, because since this function is making our list, we have to return the head of the list, because to access one singly linked list, or whatever the W or circular linked list, we need the head of the list, that is the first node of the list. Without knowing the first node of the list, we cannot traverse the whole list, or we just lost. If in case, if you not assign head as the first node of the list, and you assign this second node as the head of the list, then we will never have the track of the first node of the list. So that's why it's important to assign the head of the list and return the head while you're making the list, whatever it is, if it is singly doubly or circular linked list. Okay, so that's why we have written the return type as node as, and we have name our function name as make list, and we are not passing anything to this function, because it's just creating one list. Okay, now since okay, so assume one conditions, we are making one list. So initially, what do you think? Head and tail are null, right? Because list is empty till now. Okay, and tail should also point to null. So with that part we have done, and we will just simply write one print statement, that is enter the data in the list. Okay, so here we are asking the data from the user. Okay, so int data is equal to sc dot next int. So we have now data part which is entered by the user, right? So it's not the case that this function call will just once. Okay, so we are calling that function, we are making the list, and we are making multiple nodes inside the list. Okay, so for that purpose we will need one loop which is iterating over each time, whenever and how much the nodes you want exactly in your list. Right, so for that we will need one while loop, and this while loop will run until and unless the data value is -1. That means whenever you give the data value as -1, this loop will break, which indicates that you are done with inserting the nodes inside the list, and you want to close the list and get out of this. Okay, now if now here, after coming inside this loop for the first time, we just have to create the node, the actual node of this linked list. Okay, so we'll create the object of the node s, and I will just name it as new node s, which is equals to the new node, and according to that constructor we have to pass one data. Okay, so that data we have taken from the user over here, that we can simply pass it over here. Now at this point, line number 14, we have our list is our first node is got created. Now we have to check if one if condition is should be there, if our head equals to null. Sorry guys, wait a minute. Yeah, so if our head is equals to null, that represents that there is nothing inside the list, no node is there inside the list, and this is the first node that we are trying to insert our list. Okay, head is equals to null. So in that case we will just update the head value to the new node s, and we update our tails value also to the new node s. Okay, so this if condition will executed when there is no node inside the linked list, that is the first node that we are trying to insert the list. Okay, and now in the else part we will just simply write tail dot next equals to new node s, and after that we will write tail is equal to new node s. Okay, so in this else part, so now in this else part, when this else part get run, where if the if condition is not executed, and if condition is not executed when there is a no present inside the list, and then in that case we just have to update our tail, because head is not going to update. Head is also already assigned as the first node of the list. Over here you can see head is assigned to the first node. We just have to point the tail to the next node. Okay, so if so that is achieved in that else block. Tail dot next is equal to new node dot next. That means tail is currently pointing over here, that is the first node of the list, and this next part, tails next part means this part we are trying to assign the next value to this node value. Okay, so in over here we have simply assigned that value to this, and we are simply assigning the tails value to the new node value. Okay, so our tail should point to this new node that is inserted inside the linked list, and how we are connecting to those nodes, that is the next part. In the next part we are storing the address of this new node over here, and we are simply assigning the tails value to the new node value. Okay, so this is the part that we have to do. And after this, okay, so whenever user done with the making the list, user will enter the -1 in the console as the data value, and loop will be terminated. And after that we will simply write return head. Okay, so we'll simply return head of the linked list. Okay, and now if I write a main function, and to call that make list function I need to keep the track of the head. Okay, so head I will write the node s is equal to head is equal to make list. So since this function is returning the head, we will store that head inside this local head variable, and after this line our function got called, and our list is completed, and our list is make. Okay, build. Okay, now I hope you guys understand how to make a single linked list. In our upcoming videos we will see some more functionalities of the linked list. So thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered how to make a linked list, that is a single linked list, and so for this video we'll be seeing how to print a linked list and how to find a length of the linked list. Okay, so for the printing purpose, let me just go into my paint and let me explain you the theoretical part of this linked list. Okay, how to print the linked list. Okay, so for the printing purposes, first of all, we need the head of the linked list. So from here you will get to know what is the importance of getting the head. If you get the right head of the linked list, you can find or you can perform all the operation on the linked list. Okay, so I'm assuming you have watched the previous video where we have make the linked list, and where we have discussed about the head part. And head is basically contains the and which denotes the start of the linked list. Okay, so for the printing purpose we need that head, so that we can start printing the elements from that position itself. Okay, so for the head printing purpose we need head, and we are go on printing the head and head until we reach at one position where head is head, the node of the head which is currently there, which next is pointing to the node. That means here you can see, assume there are two nodes in this linked list. This one is head and this one is tail. And how you can find the end of the linked list? To find the end of the linked list, the it is simply nothing but the next that node next should point to the null. Whenever the node is there and whose next is pointing to the null, that denotes that that is the end of the linked list. That means we have traversed all the linked list, right, starting from the head to the tail, that is the last node of the linked list. Okay, so this is the idea behind the printing of the linked list. And to find the length of the linked list, let me just first get clear this print list. Then again we will come inside the paint and try to discuss the length of the linked list. Okay? So for that purpose we will write one more function. So this is a public static void. I will name it as print list. And since to print the linked list we need the head, so that's why we'll accept one head of the linked list to this function, and after that we will just simply print that elements of the list are, and after that we'll run one while loop, and this while loop will get executed until and unless the head is pointing to null. Okay, when the head is pointing to null, that means that is the end of the linked list. No more nodes are present after that node. Okay, we are traversing till the till we find null. Okay, so south head dot data and we'll just printing space, and we'll just write only print because we don't want our list to be printed in the vertical manner. Okay, and here if you write head dot data, that means head dot data means this is head entirely, dot data means this part. We are just simply printing the head dot data means the data part of that node. Okay, so okay, data part of the node, and once we print that we just reassign the value of the head to the head dot next. That means we are moving next forward. Okay, that means after printing this data part we will just assign the head value to the head dot next will hold the next node address. Okay, so we'll reassign this head to this node, and now the head is pointing to this node. Okay, now likewise we will go on traversing the whole list, and we will go on printing the data part of that node, and at the end we got all our node to be printed on the console. Okay, so this is the print list function that we want to perform, and in our previous video we have made the list, and now we want to print the list. Okay, so we'll just simply call our method print list, and we'll pass the head to this function. And now let's try to understand the length function of the linked list, like how to find the length of the linked list, that is how many nodes are present inside the linked list. Okay, so for that purpose, to find the length, again we need the head. Each time we need head. If you get the head, we have performed all the operation. Okay, so length function is there, we need one head. Okay, so we'll just simply write over here. Let me just write it over here. We need one head, that is a starting point of that linked list, and after that, to count the number of the nodes in the linked list, that is pretty much similar to the linked list. We'll just simply perform one while loop which will iterate through all these nodes, and it will iterate until the head dot next is pointing to the null, that is the end of the linked list. And we will take one counter variable which will count the number of the nodes inside the linked list, and each time we will increment the head to head dot next. So this is the rough idea behind the how to find the length of the linked list. So let's go and implement this function also inside our code base. So I will write public static. So this function doesn't return anything. Find length. Okay, length, and this is also accepting one head of the linked list parameter. And again, as I told you, we need one counter variable which initially assigned to 0, and we need one while loop which will iterate through the all the nodes of the list, and we will iterate until the head is not equals to null. And once the head is equal to null, that denotes the end of the linked list. And if it is not equals to null, we just simply increment the counter variable by 1, and we'll just simply reassign the value of the head to the head dot next. Okay, so this is the thing that we have to do. And after successful running of the while loop, we just have the length of the nodes which are how many nodes are present inside the linked list, that we simply print out over the console. Length of the list is light plus counter. Okay, and after this we just simply come over here and call that length method, and we'll pass that head to this function also. Okay, and now if I run this code, okay, so it is ready to run. First of all, make list function will get called here. Here you can see enter the data in the list. Program execution comes over here at line number 11. So let's suppose I'm creating one list. Okay, so let me just write one comment over here so that you guys can understand easily. I will write one comment. So we are trying to make the list like this: 1, 2, 3, 4, 5. So we want to make this list. Okay, so let's go and make this list. Okay, so I will let 1, 2, 3, 4, 5. So at this point, list is all the elements that I want to insert inside the list are inserted, and now I want to get out of this loop, which is this loop. And how to get out of this loop? We just have to give the data as -1. So if I write -1, it will get out of this loop. You can see we got one bug inside our code. Okay, let's try to debug this. According to my code, this should get out of this loop. It is not getting out of this loop. Why is it so? Let me just go through the code and check what is the problem inside this code. Okay, wait, let me just write
one run it one more time. Stop and rerun. I guess there are some issues. Okay, is it running? No, I will just rerun this. Wait, guys, it is running. Okay, so we want to enter the data. That's 1, comma 2, comma 3, comma 4, comma 5, and after that I want to write -1. So wait, guys, I will just rectify what this error. Okay, so guys, I after debugging this code, I got the error. One thing we have done a mistake over here while creating the linked list, that is we are accepting the data from the user, and we are according to that we are running this while loop. Okay, so once this while loop got run, we have to we supposed to rerun this loop and recheck the data's value, but we are not getting again the input from the user. For that purpose we have to add one extra line over here, sc dot next int. That means we are getting again the input from the user, and that input is again used as a check to this while loop. Again we are running this uh, link loop, and now if I run this main, I hope this will work this time, and I will try to create 1, 2, 3, 4, 5. So link list over. I will write -1. So here you can see the elements of this list are 1, 2, 3, 4, 5, which is printed by this print list method, and the length of the list is 5, since the 5 elements inside the list is there 1, 2, 3, 4, 5. So the length is 5. So all working fine. Till now we have covered how to make the list, how to print the list, and how to retrieve the length of the list. Okay, so thank you guys for watching this video, and I'll see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So today we are trying to learn the how to find the or how to search the element inside the linked list. Okay, so till now a quick recap. We have done how to make the list, how to print the list, how to find the length of the list, and now today we want to learn the how to search an element inside a simply linked list. So before that, we'll quickly go through the one paint and how to check how to find the or how to search the element inside a linked list, simply linked list. Okay, so now so things which are required to search an element. So first of all, we need the head of the list. Head, that is clear. We need the head of the list, and we need variables to check and to store the place at which we found that node or found that data inside the list, that is variables of type integer. And then we need one while loop where we can traverse to our whole list and check whether that node's data is equals to the data which is entered by the user, or this that is the data that is user wants to search. Okay, so these are the things that which are required to search an particular element inside the linked list. And so let's go inside our IDE and try to code this. Okay, so I will write one method public static, and we are trying to search an element, so there is no modification inside our list, and there we are not returning anything, so return type should be void. And I will write the search element as our function name, and this method should accept the head of the list, that is the starting part of the list. So at the first we will just simply print the enter the data that you want to search. Okay, so we are receiving one input from the user, that is the data that the user want to search inside this list, and we will just simply write int element sc dot extent. Okay, and int place, which is equals to, currently it is assigned to 1. Okay, so okay, and we will create one new node of temp which has the value equals to the head. Means we'll assign the value of head to the temp, and we will perform all the operation using that temp variable. Okay, and now we have our temp. We will just simply write one loop, and we'll write until our temp is equals to null. We will perform this operation. Okay, so what kind of operation that we have to perform? We are checking one if condition. If our element that we want to find is equals to the current temp dot data. If it is a condition, that means we have found our searching element, and we just simply write print element found at, and we will concat it with place variable plus th place in the list. Okay, so full stop, and after this, if we find the element, we just simply return. We don't want to perform more operation, and if that is not the case, we doesn't find our loop, sorry, the element, we'll just simply reassign the temp value to the temp dot data, or not temp dot data, temp dot next, because we want to move to the next element of the list, and we will just simply increase the count of the place by 1. Okay, and after performing this while loop, if it doesn't return, this return statement doesn't get executed, that means that element is not present inside the list. Then in that case, we will just simply print element is not present inside the list. Element is not present inside the list. Okay, so I guess this is the thing that we have to perform. And okay, so I hope you guys are watching the previous videos. Do watch them, and then only come here, because you don't understand anything what's going on. And please like and share to the series, and do comment out what is your favorite part, and what is, if you find any difficulties, also comment. I will be looking after it. Okay, so now we want to search the element, right? So we have make the list, we have print the list, we have length of the list, and now we want to search the element. Okay, so I will simply call the search element function, and we will simply pass the head of the list to that function. Okay, and now if I run this, we'll take the previous example itself. We will make the list as 1, 2, 3, 4, 5. You know what, let me just give you some more example. One notes. Okay, so we have the elements in the list as 1, 2, 3, 4, 5, 6, 7, and the length of the list is 7, and we want to search, let's suppose, 5, whether the 5 is present inside the list or not. Okay, so you can see element found at 5th place in the list. Okay, so for fifth place, 1, 2, 3, 4, 5. 5th place is 5, which is present inside the list. That is correct. So again, I will run this, and this time I will give the data which is not present inside the list. 1, 2, 3, 4, 5, 6. Okay, so element in the list are 1 2 3 4 5 6, and now if I want to find 10 in the list, so here you can see element is not present inside the list. Okay, so everything is fine working. So this is the idea of how to search an element inside a linked list. I hope you got this concept. Thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered how to search the element, how to find the length, how to print, and how to make the list. So today in this video we'll be talking about the how to reverse a singly linked list and how to find the middle node of the singly linked list. Okay, so let's get started. So to reverse a singly linked list, we what are all things that we have required and what is the logic how to reverse a string. Sorry, string, not string. It's a singly linked list. My bad. How to reverse a singly linked list? First of all, we want head that which is indicating to the start of the linked list, and again we need one while loop which is iterating over all the elements of that list, and two more variables of type node we require, which is one is previous, which will hold the previous node of the list, and one is next, which will hold the next node of the list. And after using these three variables of type node, we will just perform this reverse operation on the string, not on the string. What I'm saying is that it's a single list. My bad. Okay, so now we will go and write the code for this reverse of the singly linked list. Okay, I will come over here and I will write one more function, that is public static of, since this we want to reverse a list. After reversing a list, we want to give the new head of the list through which we can traverse the new list, that is the reverse list. Okay, so we need to return the head which is of type node. So here we have written this, and we have write the function name as reverse list, and this list will accept one parameter which is head of the list. And as I have told you, we need three variables of type node s. So let me just write those. Node s, we will write node s of current. So we need the track of current, previous, and next. So current will be equal to the head of the list, that is the current starting point of the list, and again we require node s, that is previous, which is currently pointing to the null, and one more is there, that is next, which is again pointing to the null. Okay, so now we require one while loop while our current is not equals to null. So whenever our current is not equals to null, we will perform until that we will perform this operation. What are our operation? We will assign the next to the current dot next, that is equal. That means the current where node that is pointing, it is the next node. It will point. Okay, so next will hold the next variable, next node of the list, and current dot next is assigned to the previous, that is previous will shift one step ahead. Okay, and previous is equals to current, and after that we will just simply write current is equal to next. We will move forward to the list, and after performing all these operations we will just simply return the previous, because that is the new head of the list, which is the reverse list. Okay, and after this now we will just simply need to call this method inside our main method. And to call this purpose, I guess we want to make the list, we have to print the list. I don't think so we need length of the list. That will be, I will just comment it out, and I will also comment the search part also, and I will just write reverse list. Sorry guys, reverse list, and I will pass head to it. And after this, now we again want to print the list, but with the updated head, right? That is returned by this reverse list. Okay, so I will just again call this print list method. The only thing is that here the print list will print the list in the way manner that we have given input, and here the print list function will print the same list but in the reverse manner. Okay, so let's just taste it whether it is running good. Okay, so we are entering the data 1 2 3 4 and 5. So the expected output should be 5 4 3 2 1. Okay, let's see if it is there. So elements in the list are 1 2 3 4 5. Elements of the list are 1. Wait. We are doing something error in this code. We have to reverse the list. Alright. Elements in the list are, we are printing the list, we are reversing the list, and after that we are again printing the list. Elements of the list are, we are getting only one over here. Why so? I think we have done one mistake inside our code. Let me see. We have next is equal to current dot next. Current dot next is equals to previous, and previous is equals to current, and current is equals to next. And we are simply returning the previous. I guess wait guys, I will just debug it and let you know. Okay guys, I guess I have rectified the error. I have found the error. That is, look at here, we are creating one head and we are making the list, and the head which is returned by this make list, we are assigning that to the head is. Okay, the next time we are printing the list, we are again sending that head to this method. So that head is not going to get modified over inside the print list method. Okay, but inside the reverse list method, our head is getting modified. Here you can see our head is getting modified, and our new head is our head is at 1. Okay, so our list is let me just give you a clear idea. Over here you can see 1 2 3 4 5. So our head is at 1. Okay, so to the print list we are giving our head. Okay, our head is not going to change inside our reverse list method also. Okay, but the reverse list has its own new head. Here you can see it was returning one node. Okay, so we have to retrieve that node inside our main method. We are not doing that, we are just simply again passing that head. So that head is pointing to 1. All right, so if you reverse the list, after 1 should be pointing to the null. That is going to happen by this reverse list. That's why this error was there, where reverse list is printing only 1 inside this. We just have to introduce one new node to catch the new node of the list. Okay, so new node, new nodes, let me write as news. Okay, so this node is held by this news, and we'll just simply pass news to it. Now I guess this will work fine, and our reverse list should print it on the console. And okay, now I will write 1 2 3 4 and 5, and after that I will write -1. So here you can see 1 2 3 4 5 is getting printed, which is the original list. And after performing the reverse list method on this same list, we are getting 5 4 3 2 1, which is correct. So I hope you guys found this helpful. So do like, share and subscribe to the channel, and I will see you in the next one. Thank you. Hello and welcome back to the new video of the Java tutorial series. So in our previous video we have talked about how to reverse the list, and now in this video we will be covering about how to find the middle node inside a list. Okay, So let me just go into my paint window, and I will show you how we can find the middle node of the list. Okay, so to find the middle node of the list, since it is a linked list, we cannot perform the operation that we are performing inside our array to find the linked list. That is a total elements present inside the array divided by 2. That stuff we can do inside the array, but in the linked list we cannot do that thing. So we have to find another way to find the middle node of the list. Okay, so to find this, we will try to find the middle node of the linked list using the slow and fast pointer approach. Okay, so what it does is exactly, so we need two variables of type node s, and which will call it as, let me call it as slow pointer and fast pointer. We initially assign those as the heads value. Okay, that is the starting of the list, and we need one counter variable which is count as initially assigned as 1. Okay, so we need one while loop. What will we do in while loop? While our fast pointer is not equals to null and our fast pointer dot next is not equals to null. What that means exactly is, the first node is not need should not be null, and the node which is pointing to the first node is pointing to the node, that node should be present, and that node should not be null. Okay, so these two conditions that we are going to check inside the while loop. If that two conditions both satisfies this condition, we'll enter inside the loop, and we will simply change the value of the slow pointer to the next. That means slow pointer will be assigned, new value of the slow pointer will be this next node of the list. Okay, and we'll assign the fast pointer value to the fast pointer next or next. That is, fast pointer's value will go to the third node inside the list. That is, by the name we can think fast slow pointer means we are moving slowly, we are iterating the list slowly, and the fast pointer means we are iterating the list by one node ahead, always one node ahead of the slow pointer. Okay, and after this running of this while loop, each time we will increment the count variable, so that we can have the number exactly the position where the middle node of the list is present. Okay, and after running of this while loop, we will just simply print the slow pointer data, because the slow pointer is a node which is exactly at the middle of the list, and we will also print the count variables value, which will give us the exact position of the element, exact position where the node is present inside the list. Okay, so that is the idea behind the finding the middle node of the list. So let's go inside into our id and try to code this out. So to make this function, I will write public static, and I don't think so we are returning anything. Okay, so I will write void for time being, and I will write this name as middle node, and this method will also accept the head of the list, head, and I will simply come here. So we are approaching this way in the slow pointer fast pointer approach. I will just comment it out. I will write slow pointer is equals to 1 star, and our fast pointer is equals to 2 star. That means always the fast pointer will be ahead of the slow pointer by the one node, and this will give us the exact middle of the list. And we need two this slow and fast pointer. We need this slow pointer. Initially both are assigned to the head of the list, that is the starting point of the list. And again we need one more node s fast pointer, which is also assigned to the head of the list initially. Okay, so again we need one count variable to find the position of the node that is present exactly at the middle of the list, and initially we will assign it value as 1. Okay, so and now we will write one while loop, and inside the while loop we will write first pointer is not equals to null, that is first pointer should not be null, and we will write and condition. And I hope you guys remember and condition, both the expression should be evaluated as true. First pointer dot next is should not equals to null. If that is the case, we will enter inside this loop and we will simply assign the slow pointer value to the slow pointer next. We will increment the slow pointer nodes to the next node of the list. Okay, so slow pointer is equal to slow pointer dot next, and we will also increment the value of the first pointer to the first pointer is equals to first pointer dot next dot next. That means the one node ahead of the slow pointer, and we will just count plus plus because we also want to find the position where the middle node is present inside the list. And after this run, after successful running of this while loop, we have now the middle node of the list in the name of slow pointer, which is slow pointer is exactly pointing to the middle node of the list, and the count the value of the count is equals to the position of the node that is present inside the linked list is the middle. Okay, now here we can simply write middle node of the list is slow pointer dot data, that is the data part of the list, which is at count is the position of that number. Position, wait guys, let me call yes, right, position in the list, full stop, and this will give me the middle node data and the exact position of that node inside the list. Okay, so let me call this. To call purpose, we will come inside our main method and we will call this function middle node, not make list, middle node, and we will pass the head to it. Okay, I don't think so we want to reverse this list. I will just comment it out. We will not need it this also. We just make the list, we just print the list, and we just find the middle node of the list. Okay, now if I run this, sorry, 1 2 3 4 5, so what do you think? 1 2 3 4 5 is there, and according to this list 3 should be the middle node of this list. Let's see if it is the case. Yeah, elements of the list are 1 2 3 4 5. Middle node of the list is 3. Yes, this is right, middle node is 3, which is at third position of the list. That is 1 2 3, third position of the list. So everything is working fine. Let me just run it again and give the even number of the nodes inside the list: 3 4 5 and 6, and with -1. And now you can see the middle node of the list is 4, which is right, 4, and which is at the fourth position. 1 2 3 4, fourth position, which is also correct. So this is the idea behind how to find the middle node of the list. So I hope you are enjoying this video, enjoying this series. Do like, share, comment, and subscribe to the channel. And I will see you in the next one with the new concept of the simply linked list. Thank you guys for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered pretty much concept of the linked list. We have seen finding the middle node, how to reversing the list, how to search an element, how to find the length of the list, how to print the list, and how to make the list. So till now we have covered all those concepts, all those operations which are performing on the linked list, which doesn't modifies the linked list, right? We have not done anything over here. We are just simply retrieving or checking the list. We are traversing the list till now, but from this video onwards we will start performing on the operation and to modify the list. Okay, so we'll be starting with the insertion operation first, and then we will move to the deletion operations. Okay, so basically there are three types of insertion which are done at the on the linked list. Okay, so let me just clear this first. Let me just clear this. Let me just clear. Okay, now it's fine, I guess. Okay. Now let me just create one list for you so that you guys can understand it clearly. Okay, so we are making this list, and I will write. I will make these three nodes in the list. Okay, and each these nodes are pointing to this, and this node is pointing to this, and this node is pointing to the null. Okay, I will write null over here so that you can understand. Null. So this is our tail. I hope you remember what is tail. Uh, this is head. Uh, this is the data part, and this is the next part. Okay, and this next contains the address of this node, and this is the first node. This is the second node, and this is the third node in the list. Okay, so this is our list, and we want to perform the insertion operation on this list. So basically there are three type of operations, okay, that we can perform on a list. Let me just increase the font size. We have to perform this operation on the list. Okay, so first operation is insertion at beginning, and second one is insertion at end, and third one is insertion at user specified location. Okay, so these three operations we have to perform. Okay, and now you can see these three operations we have to perform. Okay. Yeah, right. So in this video we'll be covering insertion at the beginning. So what do you think? To insert a new node at the beginning of the list, what will be operation that you have to perform? Okay, so let's write down those operations that we need to perform. So okay, and we need first of all we need the current head of the list, head of the list. Okay, and then uh, we need to make a new node inside a list. Before that we need data, which is important. We need data for the new node, data for new node, and we will make the new node, make the new node, and after that we will assign that or insert that node inside this list. Insert the node in list, and after that we will return the new head of the list, because head is going to change. Head is going to change because after performing this operation, head of the list is going to change. I will just copy all this operation that we need to perform to insert at the beginning, and I will come over here and I will just comment and paste that out. Okay, so these are the operations that we need to perform. I will just tab it over here. Okay, now it's fine. So these are the operations that we need to perform. Okay, so we'll write one function which is public static, and it will return the new head of this list. So return type should be node, and the name of the method is insert at beginning. insert at beginning. Node S will first we will take the head of the list, okay, to perform all this operation. So okay, so we have received the head of the list. Okay, we have taken this. Now we need to take the data for the new node. Okay, so we have to receive the data, right? So before that, I will print on the console, write the enter the data to insert the node in beginning. Okay, so we are asking for the data from the user to insert, which is going to insert it at the beginning of the list. And now here I will store that data into the data variable sc dot next int. And after storing the data, now second part is done. Now we have to make the node. Okay, so making the node is pretty simple. I hope you guys now know. We just have to create a new object of the new node s. Okay, wait. We just have to create a new node. Okay, new node s. Let's suppose, and we will assign new node, and we'll pass that data to the node. Okay, now it's okay, and now wait, guys. Now okay. Now once we created the node, we have to insert that node into the list. So for the insertion point of view, what do you think? I will just come to my paint. Okay, so this is the head which is pointing to the second node of the list. So if you want to perform the insertion operation at the beginning, let me just create one new node so that you can understand clearly. Here is the data part and here is the next part. Okay, now if you want to insert this node inside this list at the beginning, what all things that you have to do, you think you have to perform. Okay, so first of all you need to link this node with the current first or the current head of the list. Okay, so by linking means you have to give the address of this s next and assign it to the current head this. Okay, so this is the first step that you have to perform. We'll just write it as first step, you know what. Okay, so this linking should be done. And again, now if this linking is done and we are inserting this node at the first, we need to update the head also. Okay, so at second operation we need to reassign the value of the head to this new node. Okay, and after that we need to return the head. Now the head is pointing to this. Okay, now our current or the new node new head is this head of the list. So these are the operations that we need to perform. Okay, so first of all we need to uh, connect our new node with the current head. Okay, so Okay, so sorry for the interruption, guys. My laptop battery was dead, that's why. Okay, so now we have created a new node. We have also understood what we have to do exactly to insert this node at the beginning. Okay, so let's do this. Okay, we now create a new node, and that's next we will assign it as head. Now we at this point we have connected that new node to the current head of the that means the current first node inside the list, and now we have to just have we just have to update the head, which is head is equals to new node. This will head will pointing to the new node of the list, that is the current first node of the list, and now we just simply return head of the list. Okay, now simply return the head of the list. I hope this is the thing that we have to perform insert at beginning. Okay, now we don't have to find the middle of the list. I will simply comment it out. We just need to print the list, and now if you notice our new head is going to return by this insert at beginning method, so we have to store that new head over here. Okay, so we'll just simply write head is equals to insert at beginning, and we'll pass our head to this method. Okay, and after that we will just simply print list again with a new head. Okay, and now if I run this, okay, so 1 2 3 4 5 6 minus 1. Okay, so elements in the list are 1 2 3 4 5 6, and enter the data to insert in node in the beginning. That is a typo, you don't forget it. Enter the data. Okay, so now if I want to enter 0 at the beginning, let's see if it enters. Here you can see after giving 0 to enter at the beginning, the new list is 0 1 2 3 4 5 6, so 0 is getting inserted at the list. Okay, so this is working fine. I hope you guys understood how to insert a node at the beginning of the linked list. I hope you got this concept. Thank you for watching this video. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered the insertion operation at the beginning, and so now in this video we'll be covering insertion operation at the end of the linked list. Okay. So in our previous video I have talked about this insertion at the beginning, and in this video we will be covering insertion at the end. Okay, so let me just clear this. Okay, wait, let me just clear this thing. Okay, now we want to insert the same node at the end of the linked list. Okay, let me just erase this also. Okay, we don't require this one also. Yeah, now it's okay. So we want to perform the operation at which is insertion at the end. Okay, so things that we require. Okay, first understand that. So to insert at the end, we need first of all head of the list. Again, that is must. We need the head of the list. Okay, now we need the data that data for new node, data of new node. Okay, that is going to get inserted. Now we have data, we have the head. Now we create a new node, create a node. Okay, now we created a node. Now we insert at the end, insert at end, and at the end we will return the head of the list, return head. Okay, so these are the operation that we want to perform to insert a new node at the end of the list. Okay, so I will write it over here. I will just comment it out and will paste it, and I will give one tab, and after that we will just simply come here. Okay, so now this is the thing that we have to achieve. Okay, so now I will write my function, which is public static, and it is returning the head. That why it is of type node.s, and the name of the function is insert at end. Let me call it as insert at end. We'll simply pass node.s head of, will simply pass the head of the list. First of all, we will get the data from the user, enter the data that we want to insert at the beginning, and I'll just simply copy this line so that I can not write the new line. Okay, and over here I will just simply paste this and node in the end. Okay, and we have to insert that node, and now we will receive the data part from the user. Data is equals to sc dot next int. After receiving the data, we need to create a new node. We create the new node as new node s, which is equals to new node, and we'll pass that data to this function. Okay, and now we need to insert at the end. We need to perform insertion at the end. So what do you think? We'll go into the paint and we'll try to figure it out how to insert this at end. So two things should be there. One is, if our head is equals to null, what if the list itself doesn't have any element? That list is empty. That is, head is also pointing to null and tail is also pointing to the null. And then in that case, we will simply assign the new node to the head. That means if there is no node in the list, and we are trying to insert a new node, which is the first node as well as the last node of the list, then in that case we will just simply insert this node inside the list and we will assign it the value as head. And if in case there are some elements, there are some node present inside that list, we'll just simply we have to assign that value to the we just have to assign the current tail. Tail represents the last node of the list. We'll just simply write tail dot next equals to new node. That means we are linking this node with this node. I will just show you. We are linking this node to this node by writing tail dot next is equals to new node, and we will simply assign change the value of the tail to new node. That means then now the list becomes 1 2 3, and this node is added at the end of the list, and this node's next is pointing to the null. Now this is our list after insertion at the end. Okay, so this thing we have to achieve over here. We will write an if condition to check whether the head is equals to null. If that is the case, that means there is no element present inside the list, and we will just simply write head is equals to new node s. And now if it is not the condition, there are some element inside the list, we will just simply write we will just simply write tail dot next is equal to new node, and I will assign the tail's value to the, I will update the value of the tail to the new node, so that our list is like list is expanded. Okay, and now at the end, after performing this operation, we will just simply return the head of, new head of the list. Not new head is the this. We will just return the head of the list. Okay, and now to run this insert at the end, we are returning something head. So we need that head to be updated over here. We'll write head is equals to insert at end, and we'll pass that head over here, and we'll just simply print the list again. Okay, now if I run this, and I will give the empty list. No, not empty. First, I will give some inputs 1, 2, 3, 4. Okay, and after this, I will write -1. And now I am to insert 5 at the end of the list. That is the data. And after inserting, here you can see the new list is up printing, which is 1, 2, 3, 4, 5, and before list is 1, 2, 3, 4. 5 was not there, and after performing the insert at end operation, 5 is inserted at the end of the list. Okay, so now if I again run this, and this time I will not give any prior node in the list. I will just write -1. Elements in the list are empty, because which is not getting element list is first empty. And now if I am trying to insert 2 in the list, the element of the list are 2. Okay, so if condition is also getting executed, all working fine. So this is the way by which you can insert a node at the end of the list. So till now we have covered insertion at the beginning and insertion at the end, and in the upcoming video we will see how to insert a node at the user specified location in the simply linked list. So thank you guys for watching this video, and I will see you in the next one.
So hello and welcome back to the new video of the Java tutorial series. So till now we have covered core Java concepts. We have started with the data structures and algorithms. We have covered array. We have discussed some problems on arrays. Okay, I hope you guys are enjoying this series. So now till our previous videos we have started singly linked list. Okay, and in that we have seen how to make a list, how to print a list, how to find the length of the list, which means how many nodes are there inside the list. We have find how to search an element inside the list, and then we have started the basic operations like inserting, deleting, or finding, like that. Okay, and in inserting we have seen how to insert a node inside a simply linked list at the beginning, and we have seen how to insert a node inside a simply linked list at the end. And now again we have seen this many methods. Reverse list means how you can reverse a simply linked list, and middle node, like how you can find the middle node of the singly linked list. So these are some methods that we have seen till now. And so now for today's video I will be taking a concept of how to insert a node in simply linked list at a user specified positions, right? So for that let's just get into our paint and see the logic, how we can implement or how we can add a node inside a simply linked list at a user specified position. Okay, so this is our previous video paint. So let me just erase the things that we don't want. Okay, just we can delete this, we can delete this. Okay, fine. So let's assume that, wait, this is our link list. Okay, this is our first node, this is our second node, this is our third node. Okay, and now if I want to insert a node inside this simply linked list at a user specified positions, right? So if I say this is the simply linked list, and you have to insert this node, this one right here, this node inside this singly linked list at second position. Okay, so what is your logic, how we can think how we can insert this new node inside a linked list at user specified position? Okay, so let me just write down here. So we are trying to insert this new node at position is equals to 2. So right, so we are trying to insert this node inside the singly linked list at position number 2. Okay, so after inserting, the whole list should look like this. This is our try to follow my cursor. Okay, so this is our first node. I'm talking about the after insert method, insert operation. Okay, so that after that the link should be here, and after that this next should point to this, and after that this next should point to this. Okay, So this is the list, our list, new list, updated list after inserting a new node at the second position. So what will happen? This existing node which is at position 2 will get shifted at position 3, and new node which will be going to insert inside the list will be take that position 2. Okay, so this is the logic that we have to build. So first of all, let's get into the IDE and try to code this. Okay, so let me just get into my IDE. Okay, and I will write the similar method over here. Okay, this is insert at beginning, this is insert at end, and now I will write it over here so that you can I will and also I will be sharing this code. Don't worry, you can follow this code and try to build your own single linked list and try to play around this code. Okay, so let me just okay, fine. So we'll be let me write down one comment. So we are performing insert operation at user specified location, or to be more precise in programming language, it is index. Okay, now so since this is a method, I will write it as public. Method should be static because we are calling it inside the main method, which is static one. And think it guys, when we are updating, we are inserting a new node inside the list, so our method should also return one node that is the head of the node, that like here you can see, uh, for suppose user has inserted this node at first position, then in that case our head should also point to this, right? So our method should expected to return a new head, or the if it is inserting the node at the first position, or any case we are returning a new node. Okay, so our node is of type node s. So I hope you guys are watching our previous videos also, so that you can understand what is node s, why we are written that over there. So please watch all the video and then come over here. So I will name it as insert at the method name. Okay, and this method will also first require one head, so we are passing one linked list to this method, and in return this method will insert a new node in that list at a user specified location, right? So we are passing the head to the list. Okay, so first of all I will be requiring one variable name as position and count, and I will assign value to both as 1. Okay, so both are 1, and I will just simply write system.out.println, enter the data to insert in the list. Okay, so at this point we are asking we are printing on the console like asking the user to enter a data that we want to insert inside the list. Right, all right, and after that we will declare one data variable, and we will just write simply since sc.nextInt, and we will accept the data value of that new node, data part of the new node. Okay, and we'll after that we will simply write print on this console like enter the position. All right, so this method will what it will be doing, it will taking the data part and it will take the position, right? All right, so here you can see it will ask for the position, at which position you want to insert this node inside the single linked list that we are going to pass to this method. Okay, so now I will write position is equal to sc dot next int. Okay, so now we have covered position, we have taken the data. Okay, so now we are good to go to create a new node. Okay, so we are creating a new node s, that is a new node s, and we are passing the data
to that constructor of that node.s class. So now at this line number 104, we have created one node, and we have passed the data that is inserted by the user, and we have also taken the position from the user. Okay, now we are checking if the position is equals to 1. All right, what that means, if position equals to 1, here you can see if user enters the position that is of new node should be 1, then in that case user is trying to insert that new node at the very beginning of the linked list. All right, so in that case we have to perform some different tasks. Otherwise there are some. Okay, so otherwise we will go inside the else part. We will also code that one. Okay, so if the position equals to 1, that means we are trying to insert the node at the very beginning of the linked list. So in that case we will just simply write new node s dot next is equals to head, and we will simply reassign the value of head to new node s. Sorry for the typo mistake. Okay, so what we are doing over here is this is our new node. We will just simply assign first this next to the head. Currently the head will be pointing to the first in first node of the linked list, right? So we are making this connection first to the first node, and we are simply changing the head's value to this new node. Okay, so for after that how it gonna look like, let me just clear this mess. All right, so after that it will look like this. The head will be new node head is our new node head is this, and our second node inside the linked list will be this, and first node will be this. Okay, so now this we have covered for the position equals to 1. What if the position is not 1? Okay, or else something, then in that case we will come inside the else part, and here we will create a new node, and we'll assign it, well, name it as previous is equals to head. Okay, and in after that we'll run one while loop. Okay, and the condition we are giving over here is while the count is less than position minus 1. Okay, don't worry, I will be explaining this code in the using the paint window. All right, and we'll writing previous is equals to previous dot next. Okay, and after that we will just simply write count plus plus. All right, and after running this while loop we will simply create one more node and name it as current, and this current will point to the previous dot next. And after that we'll write new node, sorry for that mistake, we'll write new node as dot next should be equals to the current, and now the previous dot next should point to new node. All right, and after that, after this else part, we will just simply return the head of the list. All right, so let me explain what we have done inside this else part. All right, so we know if the position is not equals to 1, that means we are not trying to inserting the new node at the very first beginning of the list. Okay, so in that case what are all the operations that we have to perform, like we have seen over here. If you want to if the user gives the position as 2, so in that case first we have to simply look at over here. Okay, so we'll create one node by the name of previous, and we will assign it the value of head. All right, so at the very first the previous will come over here, previous. All right, and then which is equals to the head, like it is pointing to the first node, and after that we'll run on while loop. All right, so while we are repeating this iteration until our count is less than position minus 1. So what is our position? Let's suppose I have to insert a new node. This new node at the position is equals to 3. Okay, so look at here. My if my position is, wait, my position is 3. Now wait. Okay, so what is the count value? Initially the count value is 1. It will check whether 1 is less than position minus 1, that is 1 is less than 2. If it is correct, yes, then it will perform this two line of code. Okay, so previous is equal to previous dot next. That means our previous will jump over here. Now the previous is pointing to the second node, and count plus plus. Now the count value will be 2. And now when we again check for the condition, now this time counts value is 2. And what we are going to check, we are going to check whether the position minus 1. Okay, so my position is 3, 3 minus 1 is 2, whether my 2 is less than 2. So this time this condition will be evaluated as false. Alright, so if this condition is false, then in that case this while loop breaks and will come over here. Okay, so now our previous, which is pointing towards this second node of the list. Okay, and now we will create one more node which is current, and which will be pointing to the previous dot next. All right, so what is our previous is this, and this next part we will assign it to the what we have created another node name as current. All right, so this here our current will point over here. Current is here and previous is here. All right, now new node dot next is equal to current new node, that is our this new node dot next. So we are taking this next and we will assigning it to the current value. All right, so new node dot next is equal to current. So now our new node will be pointing towards this node, and previous dot next is equal to new node. Previous dot next is equal to new node. So if you can see, these are the two nodes that we have created, previous and current, are for taking the keeping the track of the nodes which is previous to the position that we have entered to enter the new node inside the list, and the current is the actual position at which we are want to insert that node inside the list. Okay, so after performing this operation, you can see the flow of the list would be 1 2, and this will become the third node, and this will become the fourth node. So we are successfully inserting the new node at the position is equal to 3, that is equal to here you can see. So this is logic behind this. I hope you got this. If you not, go back in the video and try to understand what we have covered. Okay, so let's run this. Let's see if we are not getting any error. Before that, I will just comment it out. We don't require this. We will make one list. We are print the list, and we'll call our method insert at, and we will simply pass the head to it. Okay, so if you notice one thing, this method it accepting one head, that mean that we are passing it over here, and but in return this is giving us a node, a new head of the list, right? It is returning the new head of the list. So that's why we have to get that new head of the list. Otherwise we are not printing the new list. Okay, so we are printing the old list that we are make over here. Okay, so this will not work. So here let me just create one new node. Let me call it as head new. So we are taking that new head, and we'll again call the print list, but this time we will pass the new head to this method. All right, so that we can print the new list after inserting the node at the user specified index. All right, so this is we want to do. Let's test it out. Okay, so it is asking me to enter the data. So let me enter 5 nodes in the list: 1 2 3 4 5. And if you want to get out of this
make list function, we have to write -1. So it is printing that elements of the list are 1 2 3 4 5. Why so? Because we are called over here print list method, which will gonna take head of the list and print all the list. Okay, so here it is asking the enter the data to insert in the list. So I want to insert, let's suppose 0, so that you guys can understand. Okay, so I want to insert 0 at what position? Let me insert it at position number 3 over here. Okay, let me insert it at position number 3. Now here you can see element of the list are, we are again calling the print list, but this time we are let me show you. We are again calling this function, but this time we are giving the new head of the list, that is the new list that our method is going to return us, that is 1 2. Then at position number 3, I have tell the program that to insert 0 at the position number 3. It is inserting the 0, and after that rest of the list will be printed as it is. Okay, so this is the idea of inserting a new node in the singly linked list at the user specified location. I hope you got the concept. Please uh, rewatch the video if you are not getting the concept, but try to understand, and I will share one trick so that you can solve these kind of linked list problems easily in once we have covered all the topics of the singly linked list. Okay, so thank you guys for watching this video, and I'll see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered how to insert a node inside a singly linked list, and that too with the all three types, like in the beginning, in the end, and at the user specified location. Okay, that is the user specified index. Okay, so one more challenge for you, so if you can try to solve it. So what is the challenge? So you have seen how to insert at end, how to insert at beginning, how to insert at user specified location, right? So now you have to insert a node in at the middle node of the linked list. All right, so what I'm telling is, let me give you an example. So if the length of the list is 10, okay, or suppose let me take it's 5. Okay, so and the elements of the list is 1 2 3 4 and 5. So at first you have to identify which is the middle node of the list. Okay, so in that case middle node is 3. I will color it up. Middle node is 3, and you have to insert a new node at the position or the index 3. So how you can solve this? I'll give you one hint. Okay, so for this operation to perform, you need to find first the middle of the linked list. Okay, so how to find that? We have covered one video. Go and check that if you watch, then it's good. Here you can see we have written one method to find the middle node of the list. So you have to somehow manage to get first the middle node of the list. You have to store that middle node somewhere, and then you can perform the similar kind of operation that we have performed at over here, where we are inserting the new node at the user specified location, right? So this is the operation that you can perform. So go and give it a try and try to solve this problem. Enough talking. So in this video we will be starting with the deletion operation, which we are going to perform on a linked list. All right, so I will just make one line over here and I will write one comment. We are performing delete operations. Okay, so for this video, we'll be looking at how we can delete a node of the linked list, which is a singly linked list, obviously, at the beginning of the linked list. Alright, so we are trying to delete the first node of the linked list. Okay, so let me just go here. This is our previous code. Go and check that video if you haven't checked. Alright, so I will just write one comment. All right, why it is not okay? All right, So I will write one comment. So we are trying to delete first node of the linked list. Okay, so we are trying to achieve this. So first thing first, let's get into our paint and try to build the logic for this. Okay, so here I no more requiring this new node, so I can delete that. Okay, wait, let me select. All right, wait, let me select this area so that I can delete it. Okay, fine. So this is our list. All right, so we are trying to delete this node, which is head is also pointing to this node, that is the first node of the list. Okay, so we are trying to delete this. So when you are trying to delete a node inside a list, the only thing you remember you have to do is you have to break the link between those two nodes. All right, so this is the link that joins this node. This is the link due to which our list is going to get completed okay, in this direction. Okay, so when we are calling our print list method, so we are passing that head, if you remember. Okay, and that head is going to get incremented at each time. And how this incrementing part is done, due to this just because of this next part. Okay, so if this next is connected to this node, then and then only we are going to move, and this is forming a chain, and this is forming a list of nodes. Okay, so we are just need to break this link so that next time whenever we pass our head, we are starting our list from this location. And don't forget to update your head, otherwise for the print list method you are passing this head, and this after this head, if you break this link, then the list will be only this part only, and your code will not work. So in that case, you have to break this link, and you have to update the heads value to the next value, because in that case, then and then only if you are trying to pass this head to the print list method, then only this is our new list that we are going to build. Okay, and this node will be discarded, not discarded, we will not have any access to this node inside this list. Okay, so this is the logic that we have to build. Let me just clear this out. I need this for the upcoming videos also. Okay, so let's go into our IDE and try to build this up. We'll write public static. So think about it, what will be the return type? So here we are changing the head, we are updating the head, that means we are doing something, uh, modification part inside our list. So whenever the modification part comes inside the list, there is one, the method should return the new head of the list, so that we can print it later onwards when we, which is required for the printing the list. Okay, so now we'll write node s. So this method will return one node, that is the new head of the list. Delete at begin. So this is our method name, and this method will also accept one head of the list. So we are passing one list to this method, and in that return, this method will delete the first node of the list and give us the updated head, so that we can print that list later on. All right, so first thing first, we will cover the corner cases. Okay, so what if my head is equals to null? Okay, so if my list doesn't contain any element, then in that case I don't need to perform any operation, deletion operation. All right, so head is already empty, then how can I perform the deletion operation? All right, so we'll simply return the null, sorry, null in that case. All right, so if this is not the case, then we are assuming that
not assuming, the surety that there are some nodes which are present inside that list, and we have to delete the first node of that list. Okay, so we will create one temporary variable of type node, and we will assign it to the value of the head. Alright, so head and temp will both pointing to the first node of the list, and we'll write head equals to head dot next, and in next part we will write temp dot next is equals to null. Okay, and now after that we will just write return head. So what I have done over here is 2-3 lines of code I will tell you. So we are first creating a new variable of type nodes name temp. So here you can see we are creating one more variable. Alright, so let me just decrease the font size. Okay, why it is not getting decreased? Alright, temp and head are both pointing to this first, these both are pointing to the first node of the list till this line. Okay, so the next line is head is equal to head dot next. So now we are changing the head's value to the head dot next. What the next part of this head is going to hold? Link to the next node of the list. Alright, so we are changing the head's value to this. So now our head is pointing towards this node. Our new head is this. So head is no more have the access to this node, but the temp variable do have access. So we'll write temp dot next is equal to null. So temp dot next, which is pointing to this node, we'll just simply write temp dot next. Now it will point to the null. So here you can see, and after that we will shall simply return head. That means we are returning this, and this causes our this is the new list. After that operation will perform. Okay, so what we are doing, we are just first of all assigning the temp, creating one new variable temp of type node, and we are assigning the value to the head, that means the first node of the list, and we are changing the head's value to the next node in the list. Okay, by using using what, using next head dot next. All right, and after that as I have told you, you have to break this link. If you want to break this link, you have to modify this next part. So for that we have written temp dot next is equals to null. So we are assigning the temp dot next to the null, so that this temp node will no more have this access to this node, and it will point to the null, and our new list will be this and this. All right, so this is the idea behind this method. All right, so let's get into our main function, and I will call that method. All right, so we are making the list, we are printing the list, and over here we are calling delete at the beginning, and we will pass that head. Okay, and after that, after passing the head, one thing you can remember, let me go there. One thing you can remember, this method is returning the new head of the list, so we have to create a variable which will be holding our new head of the list, which will be of type node s. Let me call it as new head. All right, and we will again call the print list method, and we will pass a new head of the list to this list. All right, so let me run this. I hope this will work. Let me create one list as usual, 1 2 3 4 and 5, and this is the elements. Let me get out of this, and here you can see elements of the list are 1 2 3 4 5. This method is printing using the previous head. So these are the elements that we have entered, and these are the elements that is going to print it on the console. Okay, so after that we have written this method call delete at beginning. So what it will do, it will delete the first element of the list, that is 1, and after that we are again called the print list method. Okay, so here you can see I called the print list method, and this print list method is printing the new list as 2 3 4 5. Why so? Because we have deleted this first node, we are no more have the access to this node, and new elements or the new list, linked list is 2 3 4 5. So this is the idea behind deletion of the node inside single linked list at the beginning. Okay, so I hope you got this. So in upcoming video we will be seeing how to delete a node at the end and how to delete the node at the user specified index, like we have did in the insert operations, right? So thank you guys for watching this video, and I'll see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So till now we have looked at the deletion operation. We have begun with the deletion operation, and we have seen delete at beginning. Okay, so in this video we'll be looking at the delete at end. So now what I'm talking is we have to delete the node which is at the end of the linked list. All right, so before going to the code part, as we discussed through paint, let's discuss. So to perform the delete operation at the end of the linked list, what do you guys think, what will be required? Okay, so first thing, we will require the access to the previous node, right? Like that is the second last node of the list. So as I'm assuming this linked list. Okay, so this is our linked list, and one thing, you don't get confused. Some youtubers have told you to implement this single linked list without taking the tail. They are just taking the head of the linked list. They are not assigning the tails value, and they are not maintaining the track of the tail. So and I have taught you by taking the tail. So I think this is the good idea to take tail in the linked list, so that you have at least the track of the two nodes in the list, that is the first node and the last node, so that those are required whenever you perform some complex operation on your linked list. We'll see what I mean by the complex operation. All right, so this is the list 1 2 3, three nodes are there, and this is the data part of the list, and this is the next part of the list, and this is the linked list. Okay, so we are trying to delete the last node of the list. So if you want to delete this node, we'll require the track of this node. That is the previous node to the last node. So first thing, we need the track to this node. Somehow we have to get to this loop, get to this node, sorry, not loop. And after that we can perform some basic stuff, that is we'll reassign the value of the tail to this, so that our new tail will point to the new last node of the list, and we will just simply assign this part next value to the null, so that our new list should look like this. 1 2 and second node is pointing to the null, and we don't have any more access to these nodes. So this node is getting discarded from our list, and this is our new updated list after performing the deletion operation at the end of the list. Okay, so let me get rid of this. Okay, so now we can go into our code IDE, and right beneath of this deletion at the first node of the linked list, I will make one comment and I will write it as delete at the end of the list. All right, so now since this we are making this method, and this method will be a public one and static also, and now we are deleting the node from the list. So our list is getting modified. All right, so we are getting a new list. So for that, this method will also release, or means pass, or the returns one head of that list, new list. Okay, so that we can use that head or later on to print that list. Okay, and we'll write delete at end. And this method will also require the head of the list, that is access to the list. Oops, sorry. Wait guys, wait. Delete at end, and this will require node as head. Okay, so inside this, so as we have discussed in our previous video, we are checking this if condition, that is a corner case. So what do you think, here also we have to check one corner case, right? We have to check one corner case. So what it will be, if our head is equals to null, that means if the head that we are passing to this method, that head is null, or head dot next is equals to null. Guys, what do you think, this condition will get? This is the OR operator. So I hope you know what is OR operator. Those who don't know, I will tell you. OR operator will evaluated this one expression and this one expression, and whether any OR operator, what it does simply, if any one of the condition is getting true, this if condition will be executed. All right, so if the head is equals to null, or the head dot next is equals to null, if any one of this condition is evaluated as true, this if condition will be get performed, and we will just simply return the head. Okay, and what we have doing over here is, if the head is equals to null, means this is the condition where there is no element inside the list. All right, and this, when head dot next is equals to null, that means the head dot next, that is this location is pointing to the null. So what it depicts is, there is only one node inside the list, and if there is one node inside the list, so technically we can't remove the end of the list and end node of the list. Okay, so because there is only one node present inside the list, so we can't perform this operation. In that case, we will simply return the head of the list. That means this is the condition. All right, and after checking that corner case, if that corner case doesn't evaluate it, then we'll simply create one node. I will name it as previous. So because we have discussed in our logic part, we need to keep the track of the previous node of the linked list that we are going to delete at the end. Okay, so now we have declared one variable of previous of type node. Okay, so we have to take that. Currently this is previous is pointing over here, and now if we want to delete this element, we have to get this previous somehow to this location, so that what previous will do, it will hold or keep the track of the node which is just behind the tail, that is the second last element of the list. Okay, so we are performing this while loop, so that we can keep the track of that previous until previous dot next is not equals to tail. And I hope what is tail, the tail is the last node of the list. So whenever this until we reaches to the tail, which is the previous node of the tail, we are performing this, and each time we will be doing previous is equals to previous dot next. That means we are incrementing the previous value to the previous dot next. And once we have reached to the previous node, we will just simply write tail is equals to previous, and now we will write tail dot next is equal to null. All right, and after that we will just simply return the head of the list. So here you can see we are declaring one previous variable and assigning to the value of head. We are looping one while loop, and we are taking that previous variable to the second end of the, which is the second element from the last of the list, and after that we will just simply assign the tail value to the previous. That means we are shifting our tail to over here, and we will just write tail dot next is equal to null. That means this will point to the null, this will point to the null, and this link will got broke, and we have no more track of this node which is previously at the end of the list, and our list will be like this: 1 2 and null. All right, this is the logic behind deletion at the end. Okay, I hope you got that idea. And now we will go inside the main method, and over here we will just call those methods that we have declared above, and we'll delete and end. We'll pass that head, and after that, since we are getting the new head from that list, so we have to capture that new head. New head equals to, and we'll see new head this. Okay, let me run this. Okay, so we are entering the nodes like 1 2 3 4 5, and after that I will write -1. So here you can see before performing the deletion operation, the linked list would look like this: 1 2 3 4 5, and after performing the list delete at end operation, we are printing again the list, and this time we are printing 1 2 3 4, and we are deleting the element which is at the end of the list. Okay, so this is how the deletion at end works. I hope you got this idea how it is works. So if you not get any idea, go back and watch this video again. So in our upcoming videos, we will see how to delete a node inside the single linked list which is at the user specified location. Alright, so thank you for watching this video. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered deletion at the beginning, deletion at end, and now in this video we'll be looking deletion at user specified location. Like we have seen in the insert operation at the user specified location, we are trying to delete a node which is user will tell that like this is the list and this is the position, and at the node which is present at this position you just delete it. Okay, and give me the new list. All right, so let's go. Before writing the code, as we discuss for logic inside the paint, we'll go and discuss it. So, okay, so let's suppose this is our list 1 2 3. There are 3 nodes inside the list, and me as a user gives my method the input as like this is the this is the list. You just remove the node which is present at the position 2. Like this is the node that we have to delete. All right, so in that case I want to perform the deletion operation. So now we will check what all things that we have to do. So here, if you want to delete this node, we have to break this link and this one. And if we break these links, this node will get discarded. We have no more access to this node, and after that we have to do assign value of these nodes next to this node. So this is our, so after performing this operation, what will be the list? This is our list 1 2, and we will be not having this nodes access anymore after performing that deletion operation. Okay, so these are the things that we have to do, and let's see how we can do this into our Visual IntelliJ IDEA, not Visual Studio Code. Okay, let me get rid of this. Okay, so now here we have to perform, or we have to create that method which will delete our node at the user specified location. All right, so I will just create one comment: delete at user specified location. Okay, so this method is also public one, static, and this is also going to return a new head of the list. So that's why we are writing the return type as node-s, and I will name this method as delete at
Okay, so now this method will also require head of the list, and we will perform operation on that list. Okay, so first thing first, like we have discussed in the insert operation, I hope you watched that video. And like that, here also we required one position and count variable, and we will assign both value as 1. Okay, and now we'll write system.out.println. We're asking the user as the position, enter the position of the node you want to delete. Okay, so we are asking the user to enter the position of the node that you want to delete. Okay, so after asking that position, we have to store that position somewhere. So we will be storing that position inside the position variable. We will write sc.nextInt. We will get that position from the user, and here also we will check one corner case. What is the corner case? If position equals to 1. If that is the case, if the position is 1, that means the user is trying to delete the node which is at the beginning, that is the first node of the list. So we know that how to do it, we have discussed in our previous videos also. We will simply assign the heads value to the head.next. That means like here, if the user want to delete this node, we just have to simply pass our head to the next node, and we'll simply return that node uh, from this, and from this onwards the list will be that much only, and we will no more have the track of this node. So this is the corner case that we have to check. If the user enters the position as 1, we will just simply assign the head is equal to head.next. Now if not, if that is not the case, we'll come into the else part, and we will create one node s of, we will name it as previous. Okay, and previous, and we will assign it first value to the head, and we will run one while loop while my count is less than position minus 1. So what is the condition that we are doing? Well, until my count is less than position minus 1. So here you can see this is count is 1, and position that we have entered is 2. 2 minus 1 is 1. So 1 is less than 1, which is not getting evaluated as false. We are not going inside this while loop. So this is the condition where I have a small list, right? So imagine we have 5 nodes in that list, and we are trying to delete the node which is a parent at the third index. So we have to perform this while loop at once, because we have to get that previous node to the second index, that is the previous index. That if you want to delete the third index node, you have to get that previous node to the second index node. Okay, so how we can get that? We'll write previous is equals to previous dot next, and we'll simply count plus plus, and after that while, after that coming out of that while loop, we will write current is equal to previous dot next. Okay, current is equal to previous dot next, and previous dot next is equal to current dot next. What I have done here is, I will tell you, don't worry. And after exiting out this else loop, we'll just simply return the head of the list. Okay, so this is pretty much that we have to do. So till while loop, I have told you what we are doing. We are just simply creating one previous node, and we will keep that previous updating until and unless we'll reach the previous node. Like I'll give you one example. So this is the list 1 2 3 4 and 5, and we are trying to delete the index which is 3, and this is our head, this is our tail,
and this is the position at which we want to delete the node. Okay, so at first our previous is here, so we are upgrade that previous and come that previous to the here, so that our current, this is the current, and we are assigning one current, creating one current, and current is equal to previous dot next. So after performing this step, so our current will pointing to the index at which the node we want to delete, and our previous will point to the previous node of the list. Okay, and we'll just write previous dot next is equal to current dot next. We will simply create a link of between this node and this node, and we don't have a link between 2 and 3 and 3 and 4, because the link which is created by this line is 1, 2, 4 and 5. So we have no more have the track to this third node inside the list. Because of this line we have written previous dot next is equal to current dot next, and after that we will simply return the head of the list. Okay, so this is the idea. Okay, so let me call that method delete at. We will simply pass the head of the list, and this method is also returning one head, so we have to store that new head somewhere. So I will storing over here, and after that we'll write print list, and I will pass that new head to the list. Okay, so this is the idea behind deletion at user specified location. Let's test it out. 1, 2, 3, 4 and 5. This is the list, and you can see 1, 2, 3, 4, 5 is the list elements. And let's suppose I have to delete the element which is at third index, which is at third position. So I have to delete this 3. So I have passed 3 as the position. Don't get confused, 3 is a position, not the value. So here you can see the new list is returning up after that method call is 1, 2, 4, 5. That is third position element is getting deleted. So if you don't get confused, I will just run it again, and I will write simply 55, 69, 96, 89. Now you can see now if I want to delete the 96, I can delete it by its position 1, 2, 3 and 4. Fourth position is 96, so I want to delete the fourth node of the list. Here you can see 23, 54, 69, and after that 96 is getting deleted, and 89 is again come at the end of the list. So this is the idea of deletion operation at the user specified location. So I hope you got the idea. Thank you for watching this video. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered single linked list. Alright, so let me show you. If you are watching series, so that's no problem, but those who are watching just want to learn the linked list part, those I am telling, we have covered this single linked list. We have covered all the operation. We have covered insert operation, deletion operation, both three types: insert at beginning, insert at end, insert at user specified location. Likewise, deletion operations are also performed. We have covered how to make the list, how to print the list, how to print the length of the list, how to search the element inside the list, and how to find the middle node of the list, how to reverse a list. All these operations we have performed on the single linked list, and I guess this is the pretty much idea that we want regarding the linked list. So now today onwards we are looking for the doubly linked list. So let's get started. So what is doubly linked list? In this video I'll be telling you the theoretical part regarding the doubly linked list. So let's get started. So let me create a list over here. Okay, let me create a list. We'll try to understand each concept line by line. Okay, so this is the one, this is the line, and this line. So
Okay, so till now, what we have covered is singly linked list. We know inside singly linked list, this is the node. This is node which looks like in singly linked list. There is one link which is coming from here, and there is link which is going here. That is one node is connected to this node, and this node is again connected to the another node in that list. And here, this node contains data, and here this contains next part. Okay, so why this list called a singly linked list is simple, because this node is connected to the next node via a single link. Okay, this is the single link that is getting connected to the next node. So whereas in the doubly linked list, if you can see, the node structure is different. Okay, so this is the one, and this is pretty much simple as singly linked list, but the node inside a doubly linked list is represented as like this, this, here, here, again here, and one more here. Forget about my drawing. Okay, just keep focus on the concept. Okay, this is a that is the difference. Here you have only the data and the next part contains the address to the next node in the list, and data part contains the actual data. So here also we have a data part. Likewise, here also we have data part, here also we have data part, and here also we have data part. Nothing changes over here. Here also we have next part, that is an address to the next link in next node inside the list. Here also next, and here also we have next, here also we have next, and the this part right over here, this contains previous. Okay, I will tell you what is previous, just bear with me. uh, previous previous previous. Okay, so and one more thing is there, this is one more linking over here, this which we have not seen in the singly linked list. All right, this is the this becomes the, and singly linked list is one more thing. Singly linked list, you can see, is one direction. Okay, that means if you start from left, it will go to the right only. You cannot come back in that link list. It will go from left to right. You don't have any way, like we have, you have gone to the next here from this next node, this from this next node, you cannot come back. Okay, all right, so so this is the thing that we have seen in the single linked list. But in doubly linked list, we have node like this. You can see, they just keep tracking my pointer, and each node contain previous. Previous means previous will hold the address to the previous node inside the list. All right, so if you consider this one, so in this previous part, the address of this node will be saved over here. Okay, so address of this node will be saved over here, and in the next part, the address of this node will be saved over here, and in the data part, as usual, the actual data that node is going to hold, that will get stored here. Okay, so you will be asking, what if if it is the first node, or if it is the last node, then in that case, the first node previous will hold the value of -1, and the last node of the list next should hold the -1. Okay, so this is the rough idea, doubly linked list. The advantage you get here is you can go from left to right, and you can come also backward from right to left, because this you can get this idea better. You can check it over here. This is the direction of the nodes. This is the direction of the nodes. You can see here, 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 next node, and the previous node.
The only thing is there are two ways you can go front by using the next, and you can come back using the previous. So instead of having just only one way where you are going from left to right in the doubly linked list, you have the access to the next node also and the previous node also. Why so? Because the node part of this doubly linked list contains the three parts, that is the previous part, data part, and the next part. Previous part will hold the address to the previous node in the list, and the next part will hold the address to the next node in the list. And the data part as usual hold the data, whether it should be in integer format, character format, string format, any data type format data can be stored over here. Okay, so this is the doubly linked list idea. This is the theoretical part that you need to understand before you get your hands dirty using the doubly linked list. Okay, so go one more thing. You can go in the web browser and you will just simply type doubly linked list. Let me show you doubly linked list. If you type and then first link java d point comes, and if you go here, and here you can see, oh, nice article is there which will explain all those stuff regarding the doubly linked list. I hope you got some idea about the doubly linked list. On the next video onwards, we'll be start implementing the doubly linked list using code using Java. Thank you for watching this video. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered all the operations on the singly linked list. So here you can see, I hope you guys are following the series along with me. And so we have seen how to make the singly linked list, how to print it, how to search an element, how to find the middle node, all the insert operation and all the delete operation as well. So what I'll be thinking is from this video onwards we'll be starting for doubly linked list. So we'll in our previous video we have saw the theoretical part of the doubly linked list, and from this video onwards we'll be looking for how to perform all the operation on a doubly linked list. All right, so for as we have discussed in singly linked list, we require one node which so the single linked list is made up of nodes, so we have to make a node of our doubly linked list. So we cannot use the node which we have made in the singly linked list, because in doubly linked list there is one uh, previous pointer as well as the next pointer was there, so that we can move for bi-directionally. We can go left to right, or at the same time we can come right to left as well. Okay, so for that we will be creating one Java class. So I will name it as node D. Node D means node of uh, doubly linked list. All right, so in this first of all we require data part. So I will name that variable data, and we will require two pointers, that is node D of, I will name it as previous, so that it will hold the previous address of the previous node in that list. And one more is there, node of type node D, which is next, which is as usual as we have seen in single English part. All right, so now here let me call one constructor of this class, so that whenever we create an object of this class, we have to pass the data data to this class, so that we can make that node using that data. Okay, so this dot data is equal to data, and for the first node we'll write it as previous is equals to null, and next is also equals to null. All right, so both are pointing to the towards null for the single node. Okay, so now what I'll be doing is, this is our node part, that is pretty much we have to do. And now I will go and create another Java class, and I will name it as doubly linked list. Doubly linked list. Okay, and I will hit enter. Alright, so let me just increase the font size. Let me check whether I can increase it or not. No, I guess I can't increase. I hope you guys this font is visible to you. Alright, so since we are taking input from the user, so there is one library that we have to import first. So I will import that. Import java dot util dot star. I will import every class from the util package, and now inside this we'll create object of the scanner class. Since we are making multiple methods inside this class, so I will declare the scanner object of the scanner class globally. Okay, public static scanner sc is equals to new scanner system.in. Okay, so now after creating the object of this class, uh, let me create two new variables. So those are will be public static of type node t. So I will create head and tail. So as we have seen in our simply linked list lectures, so we have here again we require a head and tail, so that we can keep track of the first node of the list and the last node of the list. All right, so now in this video we'll be talking about how to create a doubly linked list. Okay, so for that I will make one method. I will name it as public, sorry, I will do it in next line, public static. And since it is making a new linked list which is of type doubly linked list, so it must return the head of the list, so that we can get that head and print and perform all other operation that we want to perform on that list. All right, so it will return head which is of type node d, that is the node of the doubly linked list. Okay, so make, I will name it as make list, as we have seen our simply linked list lectures. Okay, and so here for the first time, whenever we want to create a list, the head and tail at initial point, those two will be pointing towards the null. And now here also I will write tail is equal to null, and after that we will simply print one line and we'll ask the user to enter the data. All right, enter the data in the list. Okay, so we are asking user to enter the data in the list, and we'll create one new variable data, and sc dot extent will take the data from the user, and again we will run one while loop, and we will iterate over this while loop until and unless our data part is -1. So whenever the user wants, let's suppose user want to insert the five elements in the list, like 1 2 3 4 5, and after that user can write data value as -1, so that this while loop will get break and our doubly linked list will be make it as 1 2 3 4 5 only. Okay, so here we will whenever we get entered inside this while loop, we know that enter data part is not -1, so there is a user who wants to insert a new node in that list, so we will make that new node d, and we will call it as new node d, and we will pass the data part that we so this is the constructor that we have built it over here. So we are passing this data to this constructor, and now after passing the data, after building that constructor, we will write one if condition, and we will write if head equals to null. So think about it, whenever head will be null, so if it head is pointing towards the null, if and only if it is the first element that we are going to that we are trying to insert in the doubly linked list, right? So in that case we will just simply assign the head value to the new node d value, and we will assign the tail value is also equals to new node value, because head ultimately this is the first node inside that list, so therefore head and tail will both point to that uh, element, sorry, not element, that node itself. Okay, so we'll write new node d dot next is equals to null, and we'll write new node d dot previous is also is equals to null. So both will be pointing towards the null. So because there is no new node inside another node inside that list, since it is the first node. Else, so whenever if head is not equals to null, that means there are some elements, there are some nodes which are present inside that doubly linked list. So we'll come inside the else part. We will write tail dot next is equals to new node d, and we'll write new node d dot previous is equals to tail. We'll write tail is equals to new node d, and we will write tail dot next is equals to null. Okay, so these are the tasks that we are going to perform if it is head is not equals head is not equals to null. So what we will be doing is tail dot next is equals to new node. So we will uh, assign the whatever the node which is at the last, the tail is there. All right, so we are assigning the tail's next value to the new node. That means we are making that link for the previous node in the list to the to that next part. Okay, and so here new node dot previous is equals to tail, and we are assigning new nodes previous to the tail. That means we are making this linkage between the last let me show you. Let's suppose let me comment it out. Let's suppose this is the list 1 2 3, and we are trying to insert 4 inside the doubly linked list. Okay, all right, so here we will, as a tail is here ultimately, since this is the last element in that list, tail is here. We'll assign the tails dot next, that means this node's next part to this new node. Okay, so we are making this left to right connection in this doubly linked list, and we'll write new node dot previous, that is this node's previous to tail. So we are making that right to left connection as well, and after making those two connections, we will simply change the value of the tail. We will assign the tail is equal to new node, because since this element is getting inserted in the list, so so this becomes the last element for now. That's why we have to update the tail, since the tail is keeping the track of the last node inside the list. All right, so and we will write tail dot next is equals to null. So we assign this next to the null, indicating that this is the last element inside the list. Okay, so these are operations that we have to perform. After performing this operation, either the if part will get executed or the else part will get executed. After that, we will again ask user to give us a new data. Okay, so it will ask again the user to enter the new data, and it will again go and check whether the data part is not equals to 1 or not. When it is equals to 1 minus 1, it will go out of that loop, and we will just simply return head of the list. Okay, so this is pretty much that we had to perform inside this. Okay, so these are the operation. I hope you got the idea how to make a doubly linked list. So let's quickly run this. So for running purpose, we require our main method. So we will write our main method here, and inside this main method, we will call our make list function. And so for our make list function, since the make list function is returning a head to us, so we have to store that head uh, in this head variable. All right, and after this, let me call this. Okay, so let's go and run this. If we are not getting any errors, we are successfully trying to okay, so here you can see enter the data in the list. Let me make a list as 1 2 3 4 5, and if I say it's done, these many elements that I want to insert this list. After that, I can write -1, and it will come out of this for loop, not for loop, sorry, while loop, and after that it will return the head to our list. So this is the idea behind how to create a list which is of type doubly linked list. Okay, so in our upcoming videos we will see all other operation of the doubly linked list. So thank you for watching this video. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered the doubly linked list one functionality, that is how to make the doubly linked list, how you can make one doubly linked list using Java. And in our previous video, as you can see, we have created a node which is of doubly linked list, which can go bi-directional, which can go from this node to this node, and it can also come back from that node to that node, that is left to right and right to left. Okay, so in the our previous video we have also talked about how to create a doubly linked list, so how to build one. So if you haven't watched that video, go and check that video. First watch that, then come back to this video. So now in this video we will be covering how to print the list. All right, so in our previous video we have built the list, so in this video we will talking about how we can print the double linked list. Okay, the logic is pretty similar to the that one that we have seen in the singly linked list. Okay, so in this video, okay, let me just first make this notes so that you guys can understand easily. All right, so let me just quickly make that list for you, and I will make it as this one, this one, this, this. By the way, guys, how you are enjoying this series? I hope. Do comment out if you have any doubts. I will clear it out. All right. Okay, so don't mind my drawing. Just focus on what I'm trying to tell you, and you will get that what I'm trying to tell you. Okay. So look at here. This is our doubly linked list. So this is the direction that we are first going. Forget about it. Let me take my pencil. This is the direction, and in this direction, this is the direction. Okay, so you can go from this direction also, and if you want you can come from this direction also. So we are trying to print this list. Okay, so first thing first, try to let's try to pseudocode this. All right, so we will try to think or build one logic. Okay, so what do you think how you can print this list? Okay, so there is one concept that I have taught you in the previous video, like this. We have keeping the track of the head and tail. All right, so if you guys can remember, head means the node that comes first in that list. Okay, so for that, here is the head, and tail means the last node of the list. Okay, so we are going to use head. You can also use tail as well, but in that case you will be printing the list in the backward direction. Okay, so in this video I will be talking how to print the list in this direction. Okay, so you can take it as homework and you can try to solve or build one logic where you can where you have the tails axis. Tails means this is the last node of the list, and you are going to print uh, list in a backward direction. Okay, so you can take it as a homework. So okay, here we'll use head. Okay, so we will run a while loop to check whether not check, to print the list. Okay, so we'll use the while loop, and you will use the head. Okay, so each time we will get to that head, we will try to print that data. Get to head, print the data. Okay, after printing the data, to move to the next node in the list, we have the next pointer, which is holding the address of the next node. So we will write logic so that data not data the head will move to the next node. Let me increase it the size of the box. Okay, so first thing first, we will get the head. We will print the data inside that node which head is currently pointing to, and we will assign head's value to the current head dot next. So we will iterate through this whole list, and when we are trying to stop, whenever our head is pointing towards a null. Okay, so when our head is will point towards a null, when when head will come here, and we will assign the new head's value to this its next node, and it's there is no next node inside this list, so head will pointing towards a null, and we can stop at that condition. Okay, so quickly we will go in our IDE and try to code this out. Okay, so we will here I will make one function or method, whichever you call it, public static. So we are just printing this list, so we are not doing anything, any operation. We are just printing the nodes of the list, so there should not be any return type for this method, and we will write print list. Okay, and since we want the head of the list as our uh, input to this method, we will get that head, and as I said told you, we will just simply print elements in the list R, and after that uh, we will perform one while loop, and our while loop will run until our head is not equals to null. Okay, so if the head is not equals to null, we'll just simply print the head's data. So we will write head dot data. We are trying to printing the data, and after that we will print one space, because so that our elements can differentiate with each other. So one space should be there, and after printing this, we will reassign the head's value to the head dot next. Head dot next. We'll assign this value to the head, so that we can iterate to the next node in the list. Okay, so if our head is equals to null, that means we are at the end of the list. We are printed all the elements. So we will just print one new line, so that whenever we will build another function, so function call gets executed to the new line. Okay. Okay, so here in to run this method, we have to call that method. We will write print list, and we will pass the head that we have stored here while making the list. Okay, so what we are going to do here, we will make the list and we will print the list. Okay, I hope there will not any error. Let's see if we got any error. Okay, so for now it's running. Okay, so now let me give the element as 1 6 8 9 4 5 6, and after that we will write -1. Okay, so here you can see elements in the list are 1 6 8 9 4 5 6. These are all the elements that I have entered over here. Okay, one thing is this is printing the new every element in the new line. I don't want that, because if there is 100 elements in the list and we are trying to print that list, it will take the whole lot of space in the console. Okay, so we'll try to eliminate that. We can do is print ln. Instead of print ln, we'll write print, and we can again call this method, so that instead of printing the each element in the new line, it will print it in a single line itself. Okay, 6 6 5 1 2 4 5 -1. We'll print the 6 6 5 1 4 5 9. These are the elements that I have entered over here, as you can see. So this is the idea how you can print the doubly linked list. So you can try to print this same list in a backward direction. You have the tails axis, that is the last node. You can build one logic and try to print this list in a backward direction. Okay, so thank you for watching this video, and I will see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered or you can say we have started to seeing the doubly linked list. So we have seen how to make a doubly linked list. In our previous video we have seen how to print doubly linked list. So what we will be doing in this video is we will try to implement another functionality of doubly linked list, that is how we can find the length of the doubly linked list. Alright, so let's go in our paint, and we'll first, as usual, we will try to build the logic by using the paint, and after that we will go inside our IDE and try to code it out. Alright, so here what you can think of how we can find the length of this linked list. So here let me get 2 3 forget, sorry about my drawing, 4. So these are the 4 elements in that in this doubly linked list. So we have to make one function that will take the head of the linked list, doubly linked list, that is our doubly linked list. It's and it will print, or it will give us, or it return the length of the list, like the how many nodes which are present inside that list. Okay, so for that we can perform it in 2 ways, like we have did in our previous video, where we are trying to print the list. I have told you we can print the list in 2 ways also, by using the head and by using the tail also. If you are going to use the head, you are printing the list from left to right, and whenever you are trying to print the list using the tail, you are printing the list from right to left, that is in the backward direction. Okay, so here also we can use both the approaches of head and tail. If you're trying to print the find the length of the list using the head, that means you are going from left to right, and whenever you are trying to get the elements, or how many elements are present inside the node, you are just from by using the tail, you are simply going from right to left. Okay, so these are the 2 approaches. In this video I will be talking about the approach that is for by using the head. You can try to solve this similar method by using the tail as well. Take it as a homework or as a challenge, you can solve it. Okay, so here for the printing purpose, we know we have head, we just have to. Okay, so first, like, we have head is given to us. All right, and now what we will be doing, we will create one counter variable. We will create one counter variable which will count the nodes in that list, and we will increment the heads value each time, and we will require while loop also to perform this operation. Okay, so idea is simple. We will run one while loop over this doubly linked list, and what we will be doing, we are just iterating over this linked list. Each time we will update the value of the head, and each time whenever we are trying to update the value of the head, which we will also increment the counter variable by +1. We will write a counter variable by +1, so that we know we have passed from one node to another node, and we will count that node as a node in the linked list. Okay, so this is the idea. Let's get into our IDE and try to code it out. Okay, so we'll make one function or method, whatever you call, public static. So this, we are simply finding the length. Okay, so I don't think so we have to pass or we have to return anything. So we will, for now we will type the return type as void, and I will name the function as length. And since we are finding the length, we need to access the head that we will get from the user. And after getting the head, as we have told, we will need one counter variable. So we'll need one counter variable. I will name it as z count, and initially we will assign it as value 0, and we will run one while loop while our head is not equals to null. So until our head will not point to null, we will perform this operation. If our head is not pointing towards the null, that means there is a node inside the list, we have to count it. So for that purpose, we will write count plus plus. So don't get confused, this is just as equals to the this one, count plus one. This is the plus plus operator that we can use whenever you want to increment the value by one. This is as similar as this. You can write both anyone from this, it will work as same. Okay, so we will write head is equal to head dot next. Okay, so we'll increment the heads to the next node. Okay, so we will performing this operation until head is not equals to null. When that head is equals to null, that means we have successfully iterated over all the nodes in that list, and after that we will just simply write the length of the list is length of the list is plus count. Okay, we'll just simply print the count value of the count over here. Okay, so this is the idea behind the length function. Okay, so let me get into our main method, and we'll call that length method, and we have to pass the head. All right, so we are passing head over here. Okay, so you guys are thinking, what if the heads there is no element present inside the list? So for that we have also covered here. We have assigned 0 as a count value. If there is no element which is present inside the list, that means our head is pointing towards the null. All right. So if the head is pointing towards the null, this will not evaluated as true, and this will not run. While loop will not run, and we'll just simply print the length of the list is 0. That means there is no element inside that list. Okay, so we will check that once we run. Let me just run this first so that you can get the idea. Let me take 1 2 3 4 and 5. Okay, minus 1. So here you can see element in the list are, that is our previous video's output. That is, we are just printing the nodes in the list, and the length of the list is 5, because 1 2 3 4 5, there are five elements in the list. We are simply printing the length of the list is 5. Okay, so we will check one more condition. If there are no nodes present inside the list, we will write -1. Simply we will write -1. That means we are not interested to uh, create any node inside the list. Okay, so element in the list are there, nothing is going to get printed over here because there are no nodes in the list, and the length of the list is also 0. So it's working fine. So I hope you got the idea how to print the length of the list, how to print the list, and how to make the doubly linked list. So in our upcoming videos we will perform some more operation, that is insertion operation and deletion operation, which we have performed in the single linked list also. So see you there. Thank you for watching this video. So hello and welcome back to the new video of the Java tutorial series. So till now we have covered we have covered the how to make the list, how to print the list, how to find the length of the list. So in this video onwards we will be performing the insertion operation on the our linked list, that is our type doubly linked list. So in this video we will be seeing how we can insert a node inside a doubly linked list which is at the beginning. So we are trying to create one method which will insert a new node in the doubly linked list at the very first position of the linked list. Okay, so assume I will take the last video output, it's paint itself. So here you can see 1 2 3 4 nodes are there, and we are trying to insert a new node in the list. So okay, so let me just create one new node quickly so that you can understand. So this here here our previous value will be stored, here our next value will be stored, and here comes our data. Okay, so look at here, we are trying to insert this node over here. Okay, so initially you can see head is over here and tail is over here. So in this video, we are looking about inserting a node in the beginning. So we don't have to take care of the tail part. We just had to take care of the head part. Okay. So look here. This is a previous. So wait, let me get my this is next. So if you are trying to insert this node inside this existing doubly linked list, so what all think you have to do? You can see this head next is pointing to this, okay, and this head's previous is pointing to the towards null. So this is that represents our first node, because the first nodes previous should always point to the null. That represents this is the first node, and that next should point to the next node of that list itself. Okay, so what we can do is we have to build the connection of here. This is our new nodes next to the this node. Okay, so we are building that connection by assigning the new nodes next to the heads value. Heads is representing to the first node of the list, and after that we have to give or assign the value of heads previous to this new node. Okay, so we are assigning we are telling that our this heads previous should point to this new node. Okay, so by doing this we have successfully linked our new nodes next to the current first node, and we are linked heads previous to this new node. Now we just have to simply get back our head. Okay, so we are assigning the value of head to this new node, so that this head will point to the new node, and this new node will become the first node of the list after the insertion operation. So these are all steps that we have to perform so that we can insert a node in the very first beginning of the doubly linked list. Okay, so let's go and try to code it out. Okay, so I will come here, I will comment it out, and I will write one comment, insert at beginning, so that you guys can understand. I will sharing this code as well. Insert at beginning. Okay, short form you can see. Okay, so let me create one method. I will come here and I will write public static. Since we are inserting a new node, all right, so we have to return the new head of the list, so that whenever next time we are trying to print that list, we will print the list from the updated head. Okay, so we have to return a new head of the list. So for that, return type should be node. We are returning a node, all right. So and we will write insert at beginning. Okay, so we'll write this, and obviously to insert a node in the list we need a existing list as well. So we'll ask for user to give us a list first, so that we can insert a new node inside that existing list. Okay, so we'll write first of all we'll ask the user to enter the data first. We are trying to insert a new node, so first of all we have to create that new node. Enter the data to insert. Okay, so after asking this, we will simply create one data, and we'll ask our user to, hey, give us one integer to that we can assign the data part of that node. Okay, so after creating this, we will just simply create the actual node. We'll name it as new node of type doubly linked list, and we will write new node d, and we will pass that data to the constructor of the node d class. Okay, so first thing first, if you are trying to insert that node inside a doubly linked list, what if the list doesn't have any elements? Okay, so how to check that case? If the doubly linked list doesn't have any elements, simply we will write head is equals to null. If head is pointing towards a null, that means that linked list has no elements, no nodes inside this. And since it is a doubly linked list, so we have to write one more condition. We have to check whether the tail is also pointing towards a null. So in that case, if both are pointing towards a null, that means the list is empty. So we will simply write head dot, sorry, head is equals to tail dot, sorry, we will just write tail is equals to new node. My id sucks, man. Okay, head is equal to tail is equal to new node. Okay, so we will assign that new node's value to the head and tail simply. Okay, that means we are trying to insert the first node inside the list, which is pretty simple. Okay, so if that is not the case, that means the list we have passed to this function has already contains some elements, contains some nodes. So in that case we will come inside this else part, and as we have discussed in our paint window, here you can see we have to assign the next part to this head and this previous part to the new node. Okay, so for that we will go and write like this: head dot previous is equals to new node. Okay, so what we have done first, we have heads previous, which is currently pointing towards a null. We will take that and we will assign the value as new node, so that this backward linking should be should get connected first, and after that we will write new node d dot next is equals to head. Okay, so what I mean by writing this is new node dot next is equal to head. So we are creating this linking now. Okay, so we are linking our new node to the existing head. Okay, and after creating these both links, we just have to create head is equals to new node. Okay, so we will just simply reassign the value of the head to the new node, because our head will change, and now because we are inserting the uh, node at the very first beginning, so our head will change. So we have reassigned the head's value, and we will just simply write new node d dot previous should point to the null. Now our new node is our the first node, so its previous should point to the null. So before that there is no element in the list, this null points that. Okay, so we will just write simply return head. We will return the head, which is the updated head. Okay, now this is the idea, I guess. Okay, so let's test it out. We will write, okay, let me comment it out. Insert ops, insert operations we are performing from this onwards. Okay, let me call insert at beginning, and I will pass the head we are taking from the previous videos itself. Okay, and now after performing this method, this method is returning one head. Okay, so we have to capture that head somehow in our main method. So we will create a new node of type d. We'll assign the new head is equals to head. So I will call it as new head, because head is already declared over here, so you can't give the same name to the again and again. Okay, and after that we will just again call printlist method, so that we can see our new element is there or not. Okay, now but this time we will give the new head, because head is updated, because we are trying to inserting that node in the first. Okay, and we will again call the length method, and we've got new head. Okay, so let's go and check it out whether it's working or not. Okay, we're trying 1 2 3 4 and 5, and after that I will give -1. So here you can see elements in the list are 1 2 3 4 5. These methods are running, by the way, I will tell you. And after that the length of the list is 5. You can see 1 2 3 4 5 5 elements are there, and now it is asking me to enter the data. Okay, so we will, let's suppose I want to enter 10. Okay, so you can see element in the list are 10 1 2 3 4 5, and the new length of the list is 6, because we have entered a new element in the list at the very first beginning. Okay, so this is the idea behind insertion operation in the doubly linked list at the very first beginning. Okay, so I hope you guys got some idea. If not, go backward and watch the video again, you will get it. If you have any doubts, ask it in the comment section, and like, share, subscribe. Thank you. Okay, so hello and welcome back to the new video of the Java tutorial series. So till now we have started seeing the doubly linked list, and we have seen some of the operation on the doubly linked list as well. That is the insert at beginning and finding the length and printing the list and making the list. So what we will be covering in this video is how to insert a node in a doubly linked list at the end of the linked list. Okay, so at the end of the doubly linked list. Don't get confused. Okay, insert at end. Okay, so this is our target. We have given one list of type doubly linked list, and we want to insert the new node in that list, existing list, at the end of the linked list. Okay, so this is the task that we want to perform. Okay, so here you can see this is our new node. This is our new node. Try to follow my pointer. Its previous is this and next is this. Both are pointing towards the null itself, and this is our list. 1 2 3 4 elements are there in the existing double linked list, and this is our head, which is pointing to the first element in the list, and this is our tail, which is pointing to the last element in the list. So remember, in our previous video we have talked about the insertion at beginning, where we have formed all the operation using the head itself, because head represents the first element in the list and tail represents the last. So in this video we will be talking how to insert a node in the last. So for that we require a tails access, so that we can perform all the operation at the last, which is at the end of the linked list. Okay, so to perform those operations, we'll just simply see how we can do this. Okay, so now first thing first, we have to check whether the list is empty or not. Like we have seen in our previous video, if the list is empty, then we'll simply assign the heads value to the new node and tails value itself to the new node. We don't have to take care of the all those things, whether it is we are inserting at the first, we are inserting at the end. Since it is the first node in the list, there is no first and last in that list. Okay, so we have to check that corner case as well. We will check that in our KA code, and else if that is not the case, here you can see this. If it is the case that there are some elements, there are some nodes which are present inside that list, so in that case we have to perform some operations so that we can uh, enter this node at the end of the linked list. Okay, so what we'll be doing, we'll assign the tail dot next is equal to new node. So this is our tail, which is currently the last element, and we'll assign the tails next to the new node. We'll make since the tails next is pointing towards a null, because since it is a last node, with this next is pointing towards null, we will make that next to point to our the new node. Okay, and we will assign new node dot previous is equal to tail. We will assign this, we will make this connections. Okay, and after making this connection, both next and previous connection, we will just simply write new node dot next is equal to null. So if we are inserting this node inside this doubly linked list, so this will come at the very end of the list. Okay, so its null next should be pointing to the null. Okay, after performing after creating those two links, we'll just simply make this next to point null. Okay, so it will represent yeah, this is the end of the list. You can't move forward. Okay, so these are operations that we have to perform. So let's go and code it out. Okay, let me get into my IDE. Okay, so we'll make one function as usual. We'll write public static, and we are trying to insert a node in the linked list. Okay, so after that we have to return a new list, that is the updated list, to the method. Okay, so for that we will write node, the return type should be node d, and we will write the function name as insert at end, and here we are trying to pass the head of the list, so that our method should get the access to the entire list by passing the head of the list, that is the first node of the list. Okay, and here we will just simply print enter the data you want to insert. Quickly I will write enter the data that you want to insert. Okay, and after that we will simply create one new variable of type data, and we'll write se.nextInt and get that data. And since we have now the data, we want to insert a new node. We have to create that node. We'll create that node like new node d, and we'll pass the data to the constructor of that node d class. And again, as I told you, we have to check the base case or the corner case. That is, if the head is equals to null, and our tail is also equals to null. That means there is no node inside the list. The list that we have given over here to this method is empty, and there is no node inside that list. In that case, we will simply write head is equals to tail is equals to new node. That's it. And if that is not the case, we will get into the else part, and we will write tail dot next is equals to new node d. And so by writing this line, what I mean is tail dot next is equal to new node d. Here you can see this is our last element, and this is next is pointing towards null, so its next is should not point to the null anymore. We will take that next and make it point towards our new node. Okay, so now the tails next should point to the new node, and after that we will write new node d, new node d dot previous should point to the tail. Okay, what I mean by writing this line is new node this its previous should point to the tail. All right, so we are trying to make this connection from the previous last node and our new last node. Okay, so we are trying to make that connection. After making that connection, we will simply write new node is equals to, not new node at next is equals to null. After making that connection successfully, we our updated last node's next should point to the null. We'll make that make it to pointing towards the nulls, and we will simply return the head of the list. That is our updated list. Okay, so let me go here. We are trying to perform insert operations. We will just simply comment it out. We don't want to insert at beginning now, and we will write node the new head is equal to insert at end, and we will pass the head of the list to this method. And after that, after performing this operation, we have to check whether the node is getting inserted at the end. For that, we have written our print list method in our previous video. If you haven't watched that, go and watch that first. Don't come and sit idle over here. And we will pass the length also over here. Okay, so we will just simply run this to check whether all these working fine. 1 2 3 4 5. Let me just give -1. So element in the list is 1 2 3 4 5, and the length of the list is 5. Okay, so here it is asking the enter the data that you want to insert. Okay, so let's suppose I want to insert 10, and I will hit enter. Okay, so here you can see element in the list are 1 2 3 4 5 and 10, and then length of the list is 6 because we have added one more node at the end of the linked list successfully. Okay, so this is the operation that we want to perform in this video. So thank you for watching this video, and I will see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So till now, we have started doubly linked list, and we have performed operation like insert at beginning, insert at end, and all those other steps like making the list, printing the list, finding the length of the list. Okay, so now in this video, we will cover how to insert a node in a doubly linked list at a user specified location. Okay, so user will give the data, and user will tell this is a location at which you have to insert this node inside the doubly linked list. Okay, so I will just simply write a comment, insert at position. Okay, we have to insert at position. Okay, so let me quickly get into my paint so that we can build the logic. Okay, Okay, I will just create 3 nodes just to give you an idea how and what we are trying to achieve. Okay, and now here let me create those nodes quickly. Okay, these are the connections. Since it is a doubly linked list, so it has one previous and next as well. It is pointing to it. Okay, don't mind my drawing. Okay, this is the this is the node that we want to insert. Okay, and here we go. Okay, so this is the node that we want to insert. So there are normally like starting 1, 2 and 3. So there are 3 elements in the list. Okay, and we want to insert this new node inside this list. Okay, so look at here how we can do this. So this is a little bit tough to understand. If you got this, well and good. If not, go and watch the video again. Okay, so we are trying to insert this. Okay, so tell me one thing. One position should be associated with it, right? User will tell that okay, so this is the node that I have to insert in this list at position number 2, let's suppose. So what that means is user want this node to be at position number 2 over here. At here, this is the node that which is currently at position number 2. So this will get replaced at position number 3, and third will get replaced at position number 4. Okay, shifting will be there. Okay, if we insert this at second position, so we have to check. So there are some corner cases that we have to first check. What if the position is 1? Okay, this is the first corner case. Look at here. What if the position is 1? Okay, if the position is 1, that means we are trying to insert this node at the very first beginning of the list. Okay, so in that case I think I don't want you to tell pretty much how you can do this. Like this is the same as we have did in our previous video where we are trying to insert the node at the beginning of the list. So we are trying to insert this node at the beginning of the list, but the thing is that we are first asking the user to enter the position. If the user enters the position as 1, that means user want this element to be at the first of the first of the doubly linked list. So you can go and code that insert at beginning part over here. Okay, so what if the position is not 1? That means user actually wants to insert that node in position where the this what we can say, where the element that we want to insert is at the somewhere middle of the list. Okay, somewhere inside the list user wants. So in that case we will code that one also. Okay, so let's go and code this. Okay, let me get into my IDE. Okay, so here we will create that method public static. So we are inserting a new node, right? So we should return the new head of the list, and we will write insert at. Okay, so this is my name of the method, and we will pass the head of the list to this method. Okay, so we are telling that take this list and insert a new node inside this list at the position that I want. Okay, so to hold that position we will create one new variable named as position, where we are dragging the position, and we will create one another variable as count, and we will assign the value of count as 1 initially. Okay, I will tell you what count does. Okay, bear with me. So we will just simply print enter the data you want to insert. We'll ask the user to enter the data. Okay, enter the data. Okay, so after that we will create one data variable, and we'll write sc.nextInt and ask the user to enter the data. Okay, so after asking the user we will again simply print one more statement, that is enter the position. Now asking the user to enter the position at which position the user wants to insert that node in the list. Okay, and we will just simply write position is equals to sc.next int. Okay, so yeah, we have asking the user. Okay, now after asking the data part, after asking the position, we just have to create a new node. Okay, new node, we'll write new node d is equals to new node, and we'll pass the data to the constructor of that node class. Okay, after creating this node, like I have said, what if the position is 1? So we'll handle that base case first. We'll write position is equals to 1, and after this, inside this, if the position is equals to 1, that means we are trying to insert that node at the very first of the very first of the list. So in that case, we will just simply write the same code as we have written in the insert at beginning. Alright, so we will write head dot previous equals to new node d, and we will write new node d dot next should point to the head, and we will write head equals to new node, and we will write new node d dot previous should point to the null. So this is the same logic that we have implemented in our insert at the beginning. If you haven't watched that video, go and check that out. You will get this. If the position is not 1, that means user don't want to insert the new node at the beginning of the list. User has tell any other location in the list. Okay, so in that case, we will we need the create the two more variable of type node, uh, and we will assign the temp value is equals to head. We'll create one temp node, and we'll assign that node, we'll assign that variable, not node, we say assign that variable's value to the head. That means this is the scenario. What I've written over here is this is the head, and we'll make one more variable. We'll assign that value to the head. That means head and temp are currently pointing to the first node of the list. Okay, so we will write node d temp2 is equals to null. We will create another variable, and we'll assign it value to the null. Okay, so we'll write one while loop. While my count is less than my position minus 1. Okay, whenever my count's value is less than position minus 1, we will simply write temp is equal to temp dot next. We're iterating the temp's value to the next node of the list, and we'll write count plus plus. Okay, so after this while loop, we will check one more condition inside that else itself. We'll check whether the temp dot next equals to null. That means when the temp dot next will equals to null, if yes, you correct, if it is the last node of the list. Okay, so if it is the last node of the list, then in that case temp next will be null, and we'll write temp dot temp dot next is equals to new node, and again we'll write new node dot previous is equals to temp. Okay, so this is the if condition. If that is not the case, we'll come inside the else part. Else, what we are gonna do, we'll create a node d. We'll reassign the temp is equals to head. Again, we are taking the temp back to the head. Okay, so not now, not temp, it's temp2. That's why I'm getting error. We have covered the temp part itself. Now we will write temp dot next. We'll assign the temp2's value to the temp dot next. Oops, I'm sorry guys, I have assigned it upper. Here I'm reassigning that value itself. I'm sorry guys, forget it. Okay, so we'll write temp dot next is equals to new node, and now we will write temp2 dot previous is equals to new node, and after that we will write a new node d dot next should point to the temp2, and finally we will write new dot previous should point to the temp. Okay, so these are the steps that we want to perform when there is a position that exists in the linked list, in the doubly linked list, which is at the somewhere in between those two nodes. Okay, so this is else part that we are going to add perform, and after get out of this loop and this else part, we will just simply return the head. That is the new list after inserting the at the user specified location. Okay, so this is the method that we required. If you know doesn't get any didn't get any idea, go back and watch the video again and try to figure it out. Okay, if you have any doubts, you can comment out. I will surely reply you back. Okay, so node D, we are getting the new head. Okay, so we will write a new head is equals to insert at, and we will pass the head of this list itself. Okay, and after passing this, now our list is changed. Sorry, typo. Print list will print the new head list, and we will also print the length of the new head list. Okay, so let's go and run this. We'll check whether it's working or not. Okay, so 1 2 3 4 and 5. After that I will minus 1. So element in the list are 1 2 3 4 5, and the length of the list is 5. That's working fine. Now it's asking for the data. I will insert 10, and let me insert this 10 at the third index, like here. Okay, so new list will be 1 2 10 3 4 5. Okay, so I will write new position as 3. Here you can see 1 2 10 3 4 5, and the new length of the list is 6 because we have added one extra node or the new node in the list at the location which I have told to the program. Okay, so this is how you can insert a node in the double linked list at position we want. Okay, so let me run once again, and we will try to give the position as 1. We'll check whether that condition is also working or not. Okay, so we'll write -1. I want to insert 10 at the first position. All right, it's working fine. It has inserted the 10 at the very first of the list, and the new length of the list is also 6. Okay, so thank you for watching this video, and I will see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So till now we have covered all the insert operation, like insert at beginning, insert at end, and insert at user specified location. I know insert at user specified location is kind of hard, but if you practice more and more, you will get how to do that. Okay, fine. So in this video onwards, we will be starting for the deletion operations, and now in this video we'll be talking about deletion at beginning. So there is a list of type doubly linked list. We are trying to delete the node which is at the first, which means the first node of the linked list that we are trying to delete. Okay, so let me get into paint. Before our code, we will try to build the logic using paint. Okay, so look at here, this is the list that we have used in the previous video, and this is the new node, not the new node. We don't require the new node anymore. Let me delete it out. Okay, so this is the list 1 2 3. These are 3 elements, and we want to perform the deletion operation at the first node of the list. Okay, so for that, to delete this, we have to somehow disconnect this this part, that we have to disconnect this node by the second node. Okay, if we disconnect this node by the second node, if there is no link between these nodes, we have lost over this we have lost control over this node. This node is no more accessible to us, and this is how we can perform the deletion operation at the first. But before that, before breaking this link, we have to somehow assign we have to change the head, because if we not change the head to this, because after deletion operation our new first node will be this, and we have to assign the heads value to this, so that we can keep the track of the remaining list. Okay, so if we not do that, and we will first, if we break the link, our remaining list will get untracked. We can't keep the track of that list again. So what we remains is only the head of the list. Okay, so this is the logic that we want to build. Okay, so let me erase this. Okay, so we will go inside our IDE and try to code it out. Okay, so we'll write one comment: delete at beginning. Okay, so we'll try to write one function, public static. So we are trying manipulating the list, so we want this list to return our new head of the list. Okay, and we will call this list name as delete at beginning. Okay, and inside this we'll write no d head. Okay, fine. So if you want to delete, I have told you you have to somehow change the heads value to this new node. So for that purpose, we will create one more variable of type node d itself, and we'll name it as temp, and we will assign the heads value to it. That means heads and temp both are pointing towards the first node of the list. Okay, so we'll check if head is equals to null. Head is equals to tail. Sorry, not null. Head is equals to tail. What do you think when the head is equals to tail? Okay, so here you can see if head and tails are both pointing to this node, that means this is the node which comes first, and this is the node which comes last. That means this is the only node which is present inside the list. There are no more nodes that exist beyond this node. Okay, so this is the case. In that case, we will just write simply tail is equal to head is equal to null. That means uh, tail and head will both point towards the null. We no more have that access to that node. That means that node will get deleted and entire list will get empty. Okay, if not, that is not the case. If there are some elements that present inside the list, then in that case we will just simply write head dot next dot previous is equals to null. Okay, head dot next dot previous is equal to null, and we'll write head is equal to head dot next. Okay, and we'll write temp is equal to not temp dot next is equal to null. We'll write this and we'll simply return our head. What I have done here is head dot next dot previous. Okay, so we are doing what we are doing: head dot next, that is this, their previous, that is this, we are assigning it to the null. Okay, head dot next dot previous is equals to null. So we are breaking this bond. Okay, we are breaking this previous bond. After that, head is equal to head dot next, we are simply reassigning the heads value to this. We are moving our head to the next variable, next node, not variable. Temp dot next is equal to null, that is temp dot next. We are breaking this next bond also. Previously we have break the previous bond. Okay, previous for bond for this node, and now we are breaking this next bond for this node, and we are successfully broke all the bonds. Okay, all the linking, and we are simply returning the head of the list. So this is the idea behind the deletion at beginning. So let's go and test it out. Okay, so let me comment it out. Delete ops Okay, and since we are getting our new head, we have to capture that head. All right, not new, what we have given the name of the method. Let me check. Delete at beginning. Delete at beginning, we will pass the head, which is we are taking from these method itself. And after that, we have to print the list. uh, but now be careful, pass the new head, and after that we'll find the length of the list with passing the new head. Okay, so these are the things that we want to perform. Just let me just run this and test quickly. We'll test. Okay, 1 2 3 4 and 5, I'm minus 1, and here you can see element in the list are 1 2 3 4 5, and list is 5 because we have 5 elements, and elements in the list are 2 3 4. One is getting deleted because we are performing the deletion at beginning, and after that list size should also get decreased by 1, which is there. And so this is how you can perform the deletion at beginning. So quickly we will check that corner case also, or the base case, where there is, if there is one element in the list, that is 1. Okay, minus 1. Okay, so here again null pointer exception we are getting. Why so? Because if there is one element in the list, list is this and this, and we are trying to delete the element which is at this, I guess we have some error. Try to fix it out, and I will tell you in the next video. Thank you for watching this, guys, and I will see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So till now we have started a doubly linked list. We have seen all the insert operation. We have started with the deletion operation also. In our previous video we have talked about how to delete at the beginning, how to delete the first node of the doubly linked list. So here you can see this is the code, and now in this video we will be talking about how you can delete the node which is present at the last. That means we have to delete the last node of the linked list. So let me comment it out. Delete the end node. Okay, so this is the thing that we have to perform in this video. So let's go and try to understand first what we are going to and what we are trying to perform. Okay, so here you can see there are 3 nodes in the list, and we are trying to perform deletion operation at the end. Okay, so we are trying to delete this node. So what do you think, how we can delete this node? uh, this is pretty simple, because we are trying to delete at the end, so there are not more operation that we have to perform. First thing, the corner case should be checked. What if there is a head and tail both are pointing to the same node? That means there is only one node in the list. That means in that case we will simply point our head and tail to the null, so that we don't have any access to that node itself, and the list will become empty. Okay, so if that is not the case, like here, if there are 3 elements present inside the list and we are trying to delete the last element, so in that case we will simply write, somehow we will break these next. Okay, so 2's next is pointing to the 3. Okay, so that's how we are keeping the track of the third node. So we will break that link. Okay, so 2's next should not point to the third node, it will now again point to the null. Okay, so it will point to the null. We'll code our method such that this next should point to the null, so that we don't have access to this node anymore. And we thirds previous is pointing to this second node. We also have to break that link also. So if we both perform both of the operation, the node will get deleted from the list, and we don't have that track of that node anymore in our list. Okay, so this is the idea behind this. Okay, so let's get into our IDE and try to code this out. Okay, so as usual we will create one method which is public and static one, and now we are trying to delete, and we have to pass a new list of the new list to the new list to the main method. So in that case our return type should be node d, and I will write our function name as delete at end, and this will get our head of the list. That means we are trying to pass the list to this method, and this method will in return delete the end element and will pass the head of the list. Okay, So to delete, let me create one temporary variable which will also point to the head first. And again, as I have talked to you, there should be a corner case where head is equals to tail. Okay, so head is equals to tail. That means both are pointing to the same node. That means there is only one element which is present inside the list, and in that case, we will just simply write head is equals to null. Okay, that means we have successfully deleted. We don't have anymore the track of that node. Okay, if that is not the case, if else part is, we will write tail dot previous dot next should point to the null. Okay, and after that we will write tail dot not tail dot tail is equals to tail dot previous. So we are switching the tails value to the previous one. So you can see we are performing this operation, we are shifting the tail. Okay, so after shifting the tail, okay, so after shifting the tail, we will write temp dot previous is equals to null. So we break that one bond also that I have talked about you. So and then simply return the head. Okay, so this is the code that we want to perform. So what I have done is we have shifted our temp to this node, and we have broke this bond and this bond also. We are no more have access to this last node of the list, and we have changed the this is our new last node of the list. Okay, so let's go and let me just comment it out. It's our previous videos function. And okay, so we will create one new node d, new node d, which is equals to the delete at end, and we'll pass the head of the list. And after that we'll print the list by using the new node d, and after that we'll find the length of the list. Okay, so these are the operations. Let me just run this quickly. We'll test it out. 1 2 3 4 5 and -1. Okay, so the element of the list are 1 2 3 4 5, and the length of the list is 5, and the elements in the list are 1 2 3 4, and we don't have any more track of this 5 because we have broke those next and previous link. Okay, now the length of the list is also decreased by 1. So this is how you can perform the deletion operation at the end of the doubly linked list. So I hope you got the idea. If not, go and watch, go backward and watch this video again. I hope you liking this series. Like, share, and subscribe. Thank you. Hello and welcome back to the new video of the Java tutorial series. So till now, we have started with the deletion operation. We have seen how to delete at end and how to delete at beginning. And now one more operation is there, how to delete at user specified location, that we are going to see in this video. Okay, so let me write a comment: delete at position. Okay, so let's go in our paint and try to see how we can build the logic how to delete the node inside the doubly linked list, which is at the user specified location. So there are two three things that we have to remember. That is the corner case first of all. So what are the corner case that we may face? Okay, so first case is, what if the position is 1? Okay, so it's a user is tell that delete the element which is present at the position 1. So that is pretty similar to the function that we have made, which is delete at beginning. So we are trying to do that same performance. We are trying to perform that same task, but this time user has given the position as 1. That means user is wanted to delete the element which is at the first. So we'll perform that same operation. And what if the user has tell to delete the last node? So this is not the actually the corner case. This will come under the default operation, because we don't know what is the end node, what is the last node, what is the length of the list. So in that case, it will come inside the default case itself. Okay, so For the deletion operation, let's suppose I want to delete this node inside the list. So I have to somehow break these and these bond, but before breaking this bond I have to link this node with this node, first node with the third node, so that this after third node all the nodes will not get discarded, because I have to keep that track as well. I just have to delete this node itself. Okay, so before deleting these links, we have to make a link between first and third node, and we have to assign thirds previous to the first node as well. Okay, so these are the operations that we have to perform before breaking those links between this next and previous of this node. Okay, so let's go and code try to code it. Okay, let's go in our IDE. Okay, so we will name it as public static. uh, we are deleting a node, right? So we have to pass open, not pass, we have to return the new head of the list, and we'll write the function name as delete at, and we will pass the new head of the list to this function. Okay, new not new head, we'll pass the head of the linked list that on which we are trying to perform this operation. Okay, so likewise at the insertion at, we need one position, which is position from the user, and we will need one count variable which is initially set to as 1. We will need one temporary variable, name it as temp, and which is pointing towards the head. Okay, and we'll just simply print enter the position of node you want to delete. Okay, we'll ask the user to enter the position, and we will simply keep that value inside the position variable. Okay, in se.nextInt. After that, we'll check the corner cases. If the position is equals to 1, that means the user wants the first element to get deleted. In that case, we will just simply write the logic that we have written at the delete at beginning. Okay, so if the head.next is equals to null, head.next is equals to null, then in that case we will just simply write head is equals to tail is equals to null. Both should point to the null, and if not, we will go inside the else part. We will write head.next dot previous should point to the null, and we'll reassign the head's value to the head is equal to head dot next, and we'll write temp dot next is equals to null. This is the corner case. If that is not the case, we'll come inside this else part, and we'll do node D. We will create one more variable which is also pointing to the head initially, and to keep that track of this back variable, we again run the while loop. So until my count is less than position minus 1, I will run this while loop. Okay, and inside this while loop I will write back is equal to back.next, and we will see simply count plus plus. Okay, so what we are trying to do is, let's suppose there are some other nodes present inside this list. Okay, so assume that there are five elements in this doubly linked list. Okay, and we are trying to delete the element, trying to delete the node which is at third index. Okay, so third position, let's say. Okay, so if you want to delete this, you have to somehow keep the track of the previous node of the list and the next node of the list. Okay, so that means we have to keep the track of the second node which is inside the list, and the fourth node which is inside the list. Okay, to delete the third one, and to keep the track of the second node, to get there, the to get there we have run this while loop. Back is also representing, which means we are trying to get the previous element. Like suppose we are trying to delete the third element, we will go there to the second element by using this back, and we'll try to hold that. Okay, and after that we'll create one more node D, where let's name it as current, which also is equals to back dot next. Current will hold the node which we want to delete. Actually, the node that we want to delete is hold by current. Now we will check one if condition, where if my current dot next is equals to null. That means it is the last element of the node that we want to delete. Okay, when the current dot next is equals to null, it is the last node of the list that we want to delete. Okay, so in that case, it is pretty simple to that we have done in the delete at end. Okay, so in that case, we will just write simply dot current dot previous is equal to null, previous dot current is equal to null, and we will write back dot next is also is equal to null. Okay, and if that is not the case, there are some nodes which is present after that current also, then we will come inside the else part. We will write back dot next is equal to current dot next. We will current dot next. So what this means is we are trying to break the next link, and we are trying to make the linkage with the fourth node. Okay, so we are no more have the track of the from second to third node. We have built the connection from the second to fourth node by writing this line. Okay, and after that we will write simply current dot next, current dot next is equals to current dot next dot previous is equals to back. Okay, so this is the case that we want to perform, and after that we'll just simply come out of this else part, and we'll just simply return the head of the list, and we are done with the operations. Okay, so this is the deletion operation at the user specified location. Let me just comment it out, and since we are getting the new head of the list from the function, we will just simply write node D, new head D, and we will write delete at, and we'll pass the head, and we'll just after that, after performing this operation, we have to check whether the node get deleted. We have one print list method that we have implemented also, and we'll also find the length of the list, whether it is decreased by one or not. If it is got declared, that means our node is successfully deleted. Okay, so we will run this. Okay, so 1 2 3 4 and 5, and give it -1. So element in the list are 1 2 3 4 5, and the length of the list is 5, and it is asking for the position that I want to delete. So let me give a position as 3. So delete the element which is present at the position number 3. So here you can see the position number 3 is present. It has deleted. Don't get confused, this is not the data part. I am giving the position, I am giving the actual position at the third position, whichever node is there, delete it, and after deletion operation 1 2 4 5 is getting returned by the list, and list size is also decreased by 1. So let's go and check the corner case also. What if we want to delete the first element of the list, that is 1 2 3 4 and 5, and after that -1, and we will give 1. Here you can see 2 3 4 5 is also printed, 1 is getting deleted, and the length of the list is also decreased. So this is how you can perform the deletion operation at the double linked list at the end of the list, or at the user specified location, or at the start of the list. Okay, whatever position you want, you just give the position. If that position exists inside the list, this function will delete it. Okay, so thank you for watching this video, and I'll see you in the next one. Okay, so hello and welcome back to the new video of the Java tutorial series. So till now, if you are watching this series, that's great. We have covered the core Java concept. We have started with the DSA part. We have covered arrays. We solved some problems using arrays. Now we are at the linked list part, and now we have covered single linked list and doubly linked list successfully. And now from with this video onwards, we'll be covering the circular linked list. So okay, so for this video agenda will be I will be talking about how the circular linked list works, what are all the things that you want to learn about the circular linked list. That part we will go and learn in this video. Okay, so let me just adjust my paint window. Oh yeah, that's fine. Okay, so what we have seen till now. So we have seen the circular linked list, we have seen the doubly linked list, and now we are going to see the circular linked list. Okay, so let me just give you the overview. And one thing, if you have not watched our previous video, go and watch them first so that you can get clear idea uh, of the what is single linked list and doubly linked list, and so that you can clearly understand what is the circular linked list. Okay, and one more thing, if you are watching this series and loving what content that we are providing, so please like, share and subscribe, and please share this series to your friends as well so that they can get also benefits of this series. Okay, and if you have any doubt, do let comment it out. I will definitely get back to you. Okay, so here you can see I have created one linked list. So as you can see by this, if you are watching this series, you can clearly guess it. What is it? It is a simply linked list. Okay, so there are these nodes. These nodes contain the data part and the next part, and the next is holding the address to the next node. Okay, so this is simply the simply linked list. So now I will do one simple thing, and I will change this simply linked list singly linked list to a doubly linked list. Okay, so here you can see I will just wait a minute, guys. Okay, so by adding just one extra line and one extra partition in the node, we are creating a doubly linked list. Okay, so what is doubly linked list? It is nothing but we can go forward and come backward as well. In the single linked list, you can go only from left to right. Okay, there is no way you can come from back from there. If you want, you can come, but there is no simultaneous way. Okay, so now here what is in doubly linked list? Doubly linked list does the same. It holds the value of the next node, and at the same time it holds the value of the previous node also. Okay, so you know what is next to it and you know what is back to it. Okay, so it holds the previous address as well and the next address as well and the data part. So this is the doubly linked list, and now I will do one little modification in this so that it will make it as a circular linked list. Okay, I will do like this. I will get this and I will just simply assign it to this. Okay, so what I have done here is simple. Okay, try to understand. Okay, this is our doubly linked list before joining this line, and I have created one simple line, and I have joined the tail, that means the last node, to the first node. Okay, so the tails dot next, before joining this line, this is doubly linked list, and tails next is pointing towards null. So instead of pointing to the null, it will pointing to the head. Okay, so that it will make a circle. Okay, and this previous is pointing to this, and its previous will point to the last node. Okay, so we have make these two changes in the doubly linked list, and it will make it as circular linked list. Okay, so what we have done is we have link the tail dot next to the head of the list, that is the first node of the list, and we have given the value of head dot previous, that is heads previous, to the tail. That means we are trying to connect head with the tail. So by doing this, we are making a circle. You can see if you are trying to iterate from the head, and you are going to iterate, and you come at head. Okay, so this will make it as circle. Okay, this will form a circle. Okay, and if you see it is forming one circle. You are heading, you are starting from the first node, you go to the second, fourth, then third, and then fourth, and due to we have link from this to this, and it will again come back to the head. Okay, and it is also in the backward formation also. If you are at the tail, you go here, go here, go here, and it will also come here. Okay, so this is the idea behind this. And one more thing that I forgot to tell you, there is no backward. Okay, so here you can see we have created doubly linked list. Okay, so there is no backward, you can't come backward, there is no previous in the what we can say is circular linked list. There is only one way, there is only one way, you can go from left to right, you can't go you can't come backward. Okay, so circular linked list, in simple terms, circular linked list is nothing but uh, one little modification to the single linked list that will make the list linked list as makes it circular. Okay, it go in the loop and all the elements are connected with each other and list is also connected. Okay, so this is the theoretical part of the single linked list, sorry, the circular linked list. So this is it. So there are two types of circular linked list. One is singly circular linked list and doubly circular linked list. So here you can see I have given you the example of the singly circular linked list. Okay, singly circular linked list is nothing but the single circular linked list, but in the circular format. Okay, so we are trying to connect these ports, and if I redo, okay, so this is also a circular linked list, but it is in a doubly format. That means it is a doubly linked list that we have connected tail and head so that it will make and work as a circular doubly linked list. Okay, so this is the idea behind the circular linked list. So thank you for watching this video, and from the next video onwards we will try to implement this. Thank you.
Hello and welcome back to the new video of the Java tutorial series. So in our previous video, we have started seeing circular linked list, and we have seen the theoretical part of the circular linked list, and we have understood what is circular linked list and how we can implement it. All right. So in this video, we will be start coding with a circular linked list, and in this video, we will be creating a circular linked list and know how to create a circular linked list. Okay, so for that, let me just create one visual representation of the circular linked list so that you can understand more clearly. Okay, so again, we can implement circular linked list in two ways using circular singly linked list and circular doubly linked list, meaning that you can convert a singly linked list into a circular singly linked list, and you can convert a doubly linked list into a circular doubly linked list. The difference is only between the you have to keep the two pointers. All right, if you are implementing the doubly linked list, circular doubly linked list, then you have to keep the track of previous and next. And if you are implementing just a singly circular linked list, then you have to keep a track of only the next pointer. Okay, next address of the node. Okay, inside the this. And one more thing after that, this will get connected to the first node. So as we know, we have one head and we have tail. All right, and the head representing to the first node of the linked list, and tail representing the last node of the linked list. So it's like an linked list. We will be implementing the singly circular linked list. You can try the doubly circular linked list by your own. Okay, so look at here, we have one singly linked list. Okay, this is the first node, second node, third node, and fourth node. So to make it as a circular linked list, circular singly linked list, we just have to keep the track of tail dot next, or we have to assign the value of tail dot next to the head. That means it will create one circular list. Okay, so we are going from first node, second node, third node to fourth node. Again we can come back to the first node, so it making a circular linked list. Okay, so this is how we can create a circular linked list. So let me go into my IDE and we create one circular linked list over here. Okay, so I was in my IDE, and let me just right click here and create a Java class
So as you have seen in our singly linked list and doubly linked list, we need a node to create a linked list. All right, so let me create one node for the circular linked list. So let me create the class name as node c dot java. So this will represent our node, one node inside a list. Okay, so for the circular linked list, we are implementing circular singly linked list. So that's why we required data part and one uh, one next variable of type node c itself, which will carry the address of the next node inside the list, and we want the constructor for this class, and this constructor will take the input as the data from the user, and it will just simply assign that data to the data that we have declared over here. Okay, and we'll assign next is equal to null. All right, so this is the node c dot java file that we are using. Okay, so now after creating the node, I want to create one file where I can perform all the operations regarding to the circular linked list. All right, so let me call it as circular linked list dot. Okay, so here I created it. So since we are getting the input from the user, so we do require the scanner class also. So let me just go ahead and import my scanner class. I will write import, sorry for typo, import java dot util dot scanner. So after importing the scanner class, I do require my main method to execute this code, and we will implement this main method later, and just I will do for declaration part first. So we are taking inputs in a multiple method, so I will declare the object of the scanners class globally. Okay, so it's public static scanner sc equals to new scanner system.in. All right, so we have declared the object of the scanner class as well, and now we have to declare those two variables of type node c representing the head and tail, which is the first and last node of the linked list respectively. Okay, so we'll write public static, then those are of type node c, and we require the head and tail. Okay, so this is also done. Now we are good to go to write those methods. So in this video we'll be creating a circular linked list, so that's why I will write uh, comment create circular linked list. CLL is circular linked list. Okay, so this method should be public and static one, because we are calling that method inside the our main method, which is static as well. Okay, so and since we are making the list and we have to return a node that is the head of the list, so that's why we are returning a node. So the return type should be node c, and the method name I will call it as make list, because we are creating a new list. Okay, and just create the method. Okay, so initially the my head should point to null, since we are making a new list, so the head and tail should point to the null. And okay, and after that I will just print enter the data in the list, enter the data in the list. Alright, so I will just write it over like this. So and after that I will declare one int data variable, and I will take it a input from the user, and after taking this input from the user I will just write one while loop, and while my data is not equals to -1, until that I will run this while loop, and after getting inside this while loop I will create a node which I need to insert inside my linked list. Okay, I will call it that node as new node c, which is a new node of circular linked list, and will equals to new node, and so we have to pass the data to the constructor of that node C class. We will pass the data that we have taken input from the line user from in line number 12. Okay, so after creating the node, we'll check one if condition. If my tail is equals to null, if that is the case, my tail is equal to null. In that case, I will just write head is equals to new node C, and we'll write our tail is also equals to new node C. Okay, so what I have done is, and one more thing, we write new node C dot next is equals to head. Okay, so when my tail is equals to null, that means it is the first node that we are trying to insert our list into our list. And for the first node, we don't have to do anything extra. We just assign the head to the new node and tail to the new node. Both the head and tail will point to the first node of the list, because there is only one node inside the list at this time only. And we'll write new node dot next is equal to head. Since we are making the circular linked list, if this is the node that is uh, there inside the list, then it should there this next should point to this node itself. Then and then only it will make the circular motion in the linked list. Okay, so for that we have written over here. And if my tail is not equals to null, then we'll go inside the else part. That means there are some nodes which are already present inside my list, and then in that case we'll just simply write tail dot next is equals to new node. We'll update the tails value, or we make that connection between the previous node and the new node we are trying to insert. And after that we will write the update the tails value to the new node C, because we have to move the tail. And after moving the tail, we will write the tail dot next should now point to the head of the list. By writing the line number 22, we are again making that circular motion inside our linked list. Okay, so after doing this, we will again take the data from the user, uh, and we will continue implementing this while loop until the user is satisfied and entered -1, uh, just to represent that user have done creating the list and user want to exit from this loop. Okay, and after creating all this, we will just return the head of the list, that is our linked list. Okay, so now if I go inside my main function, and I will just write node node C, which is the head, and I have to get this method is returning the head that I have to capture over here. I will capture over here, and I will write make list. I will call that make list function over here. And if everything goes fine, this should not give me any errors after running this. Let's hope it will not throw error, and let's run this. Okay, so it is asking for me to enter the data. So let me just go ahead and enter the data over here. Let me write 1 2 3 4 5 6. I can enter as many data as I want, and after once I satisfied from entering the data, I will just simply write -1. So I will get exit from the code, because after line number 30 there is no line that we are executing. Okay, so this is pretty much idea behind the circular linked list, how to make a circular linked list, how circular linked list works. Okay, so in our upcoming video we will see how we can print this circular linked list. Okay, so the printing part is tough, because there is no uh, null to the tails dot next, because we are always telling that tails dot next should always point to the head. So we are making the circular linked list, so we have to somehow figure out how we can manage to stop at which point, and how we can predict the end of the list. So okay, so we'll see that in our next video, where we will be seeing how we can print the circular linked list. Okay, so thank you for watching this video, and I will see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So in our previous video we have talked about how we can create a circular linked list in Java. Okay, so now in this video we will see how we can print that circular linked list that we have created in our previous video. Okay, so let me just go ahead and clear this out. The previous topic, I will delete it, and our new topic is print the circular linked list. Okay, CLL is the shortcut that I have used for circular linked list. Okay, and now if you can see, imagine this is our circular linked list. Node number 1, 2, 3 and 4. Okay, so and fourth is connected to the head again, that is the first node. So if we are using the logic that we have used in our previous videos of doubly linked list or else singly linked list to be precise, then you can see we are just iterating over the nodes until we get the head dot next as null. So that's logic is good for the singly linked list, where we are denoting the end of the list as last nodes next should point to the null. Okay, so but now in the circular linked list, when we traverse to this nodes, we can't use that logic because there is no null. We are representing that tails dot next as the first node. So it will, if you implement that logic here, it won't work. It will go inside the infinite loop of printing all those node again and again. Well, it will print 1 2 3 fourth node, and it will again print 1 2 3 fourth node. So you have to somehow figure out how you can stop that while loop from printing the nodes. Okay, so to figure out that logic, one thing you can do is you can increment the head as it is that we have doing in our singly and doubly linked list. You just go on incrementing the head and until your head is matches to the null. Okay, so until your head is at the position of where our tail is currently, then and until then you can iterate over the list. And as a when you come here, when your head come here at the position of tail, you just print that last node's value and you just get out of this loop. Okay, so this is one way you can achieve printing of the circular linked list. Okay, so we'll be implementing this approach in our code. Okay, so let's go in our code and try to code it. Okay, so this is our circular linked list method that we have implemented in our previous video. I hope you see that video and understood how we can implement the circular linked list. Okay, so for printing purpose, I will again create one method, a public static, and we are just printing the list, right? So this method should not return anything, and after I will call this method as print list. Okay, and we are printing the list. For that purpose we have to access the head. Okay, so do require head of the list so that we can start printing our list from the head onwards. Okay, and now you you can imagine one corner case, right? So imagine our list doesn't contain any node. Okay, so there are no nodes inside our list. Then in that case we have to handle that corner case. We can simply write if my head is equals to null. In that case you just simply return. I don't want to do any processing or any printing stuff. If my head is equals to null, uh, otherwise if head is not equals to null, if there are some elements which are present inside the list, we just print them as it is. Okay, sorry guys. Elements in the list are okay. uh, okay, here we come and we will define one while loop, and according to our approach that we have seen inside paint, we will write head until my head is not equals to tail. I will do the stuff. Okay, so what we are doing, we just go ahead and print. I will remove the print element so that it will not print the each and every element in the new line. Okay, and I will write head dot data. We print that head dot data, and we print one space also, so that we can differentiate between all those elements which are printing in one line itself, and after printing that we will again increment the heads value to the head dot next. Next. Okay, so okay, you can see we are iterating until our head is not equals to tail. Okay, so again I go inside my paint. When I come here, it will check head is not equals to tail, but it is equals to tail. Then it will terminate this while loop and it will not print the last node's data. So each time we have to take care of that. We have to print the last node's data as well. So to print that data, we will just come below the while loop and we will just print that data. That is head dot data. Our head is currently at tail, but we have written the condition like that. We have written that head is not equal to tail, but this head is equal to tail, it will not execute this while loop for the last node. For that we have to again write that print statement over here, and we will just simply uh, print one new line just to understand the clearly. Okay, and this is how we can print the list. So let's go ahead and check our method is working or not. If we got any errors, we will rectify that as well, and we will pass the head of the list that we are getting from the making the list. Okay, and now if I go ahead and click on run, okay, it is executing. Okay, so let me create my list as 1 2 3 4 and 5 6. Okay, and after that I will write -1. So you can see element in the list are 1 2 3 4 5 6. In we have implemented the circular linked list. We have the access to this. After 6, it is connected to the one that is first node of the list. Again we are printing that using this condition, and we are printing here the last node of the list successfully. So this is how we can print the circular linked list in Java. Thank you for watching this video, and I will see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So today in this video we will be covering, we will be seeing one method which is how we can find the length of a circular linked list. Okay, so length in the sense that we have to find how many nodes are there inside that circular linked list. Okay, so again if you recall our previous videos where we have seen singly and doubly linked list, how we can do that is we have one counter variable which will count all those nodes present inside this linked list until and unless we reaches the end, which we representing as tail dot next is equal to null. Okay, so we are iterating over that linked list until we reaches at null. Okay, so for but now we are seeing the circular linked list where null doesn't exist. We have tail dot next is which is assigned to the head, which makes this as a circular linked list. Okay, so how we can do is do this in to find the length of the circular linked list. If we again if you follow this approach that we have been using in the circular linked list, no, sorry, single linked list or the doubly linked list, then your loop will go in infinite loop. It will go and count again and again, because you never stop by using that approach. There is no null. Okay, this will count as 1 2 3 4, again it will 5 6 7 8. The loop will never stops. Okay, so what we can do is we can use the logic that we have used in our previous video. That is to we have used that logic to printing that list. Okay, so if I go inside my IDE, I will show you so in our previous video we'll see how we can print the list, right? So for that we have used the logic as head is not equals to tail. So we are iterating over this list until my head reaches to the tail, and after once the head will reaches at the tail, we'll just simply get out of this loop and we will just print the last node's data. So we can use this logic as in our finding the length of method. Okay, so we'll see how we can do this. Let's go and create one method, but let me first go ahead and create one. Okay, just wait a minute. Let me go ahead and create one method comment over here so that you guys can understand what we have done in this method itself. uh, you know, print the circular linked list. Okay, so in this video we will be creating finding the length of the list. Okay, so I will write length of circular linked list. Okay, okay, just we'll go and create our method. Okay, so 2 minute. Okay, public static. So we are finding the length of the list. All right, so I don't think we have to return anything. Okay, so initially we'll keep the return type as void, and after that we will write our method name as length. And now to find the length of the list we have to get access of that list. So how we can get access of the list is by getting the head of the list. All right, so we'll receive the head from the user, and I will again just initialize one counter variable, and I will name it as count, and again initially I will name it assign it zeros value. And now if you imagine one corner case is there. Okay, so what is that? It's if my head equals to null. All right, so initially the head which is given by the user at line number 44 is null. Okay, so that means there is no node in the list. The list is empty. So in that case we just simply return. We don't have to do any processing part in this method. So we will just write head equals to null. We will just simply write return. Okay, and if that is not the case, that means there are some nodes present inside the list. We will just write our while loop, and we will write until my head is not equals to tail. I will do the processing part. Okay, so what processing part that we have to do is we just have to increment the count value by 1. So how we can do this? We will just simply write count plus plus. We can increment the count value by 1, and again we have to increment the head as well. Head is equal to head dot next. Okay, so just to understand, if you guys can understand, here also in our previous video we have left with the one last node that we have printed over here. So here also we will be left with one last node that also we have to count. So again once we get out of this while loop we will just simply write one count plus plus as well, so that we can cover the last node of the list as well. Okay, and after that we will just simply print the counts value. So we will just simply write the length of the list is, we will append this as with count. Okay, and after that we'll just simply print one new line so that execution goes to the next line and we can understand things more clearly. Okay, so that is the idea behind finding the length of the circular linked list. Let's check whether our method is working fine or not. We will go inside our main method and we'll just write length, call that method, and we'll just pass the head that we are getting from making the list over here. That will be pass head over here. Okay, so let me run this code. uh, Let me call my list as one. Wait a minute, my numlock is will again run this. Wait a minute. Okay, 1 2 3 4 and 5, and I'm done with the printing the list. And you can see element in the list are 1 2 3 4 5, and the length of the list is 5 because we have 5 elements inside the list. Okay, so this is the idea behind finding the length of the circular linked list. Okay, so in our upcoming videos we'll see how we can perform the insertion operation or deletion operation on a circular linked list. Okay, so thank you for watching this video and I will see you in the next one. Hello and welcome back to the new video of the Java tutorial series. So in our previous video we have seen how we can find the length of the circular linked list, and now in this video we will be starting with the insertion operation on a circular linked list. And now in this video we will see how we can insert a node at the beginning of the circular linked list. Okay, so before going to the coding part, let me just show you how we can find the how we can insert a node in a circular linked list which is at the beginning. Okay, so it is pretty different from the ones that we have done inside a single linked list or the doubly linked list, because in our circular linked list we have connected our tails dot next to the head. Okay, so and if you are trying to insert a new node, let me just create a new node. Wait a minute. And now imagine if you are trying to insert this node at the first at the very beginning of the linked list. So in that case, the you have to perform three operations. Okay, so the first operation is you have to assign the tail dot next value to the new node. Tail dot next is equal to new node that we are going to create, so that it will create that circular motion in it will maintain the circular motion inside our list. And after that, after creating that link, we will just assign the new node dot next, that is our new node dot next is equals to head. Now once we have created this linking, tail dot next is equal to new node, and then we have to assign the new node's next value to the head of the list, that is the current first node of the list. And after that we will just simply write head is equal to new node. We will change the value of the heads to the new node, and our list becomes like this one. And this is our first node, this is our second node, third, fourth, fifth, and again this tail dot next is pointing to the new node, so as to maintain the circular motion inside our circular linked list. Okay, so this is how we can achieve this insertion inside a circular linked list at the beginning position. Okay, nice. Okay, so now let me go inside my IDE and we'll try to code this out. Okay. Okay, so below my length function, I will just write one comment, which is insert at the beginning. Okay, we're trying to insert at the beginning. Okay, so let me go ahead and create one function. This function is public one, public static, and we are trying to insert a new node inside the list, and that's why we are also changing the head of the list. So we have to return the new head of the list to the main method. So the return type should be a node. We are returning a node to the main method. Okay, and I will call this name method as insert at beginning. Okay, and we have to get access of that list, so to change the list. Okay, so insert the node at the beginning. Okay, now inside our method, one thing we can do is we have to insert a node, right? So we have to get the data for that node first. So we'll just simply write system.out.println. We'll write enter the data to insert at first. Okay, so we are inserting at the beginning, that's why I write first. And after that we will just write int data is equals to sc dot next int. Okay, and after that we are good to go to create the node. Okay, so we'll create the node, new node c, let me call it as new node c, and which is equals to the new node c, and you'll pass the data that we have get from the user. Okay, and again there is one case where our list doesn't have any elements. Okay, so we have to handle that case as well. That case we can handle by writing head is equals to null. That means our list doesn't contain any elements, and the node which we are trying to insert our list is the first node of the list. Then in that case we will just simply write head is equals to new node c, and tail is equals to new node c, and we'll write new node c dot next is equals to head. Okay, so that we can maintain that circular motion inside our linked list. Okay, so if that is not the case, that means we have some element inside our linked list. Okay, so in that case, as we have discussed, we just have to write tail dot next is equals to a new node C, and we will just simply write new node C dot next is equals to head, and we will write head is equals to new node C. Okay, fine. Once we have done with that one, now we can go ahead and return our head to the main method, which is the updated head of the list. Okay, so we come inside our main method and we will create one blank space, and we will write at line number 82 as we will call that method, which is insert at beginning, and we'll pass the head of the list. Okay, so remember one thing, this method is giving us the new head of the list, so we have to capture that new head. Okay, so we capture that new head inside this. Okay, I will name it as new head. Okay, we have to capture this new head over here. Now it's okay, and we can go ahead and again call those methods of print list, but now we have to pass the new head, so it has to print the new list, that updated list, after inserting the node at the beginning. And we will again call the length method, and we'll pass the new head to this method as well. Okay, so we'll see before and after whether it gets added or not at the beginning of the linked list. Okay, so this method first call is given to the 78 number, and now we are creating our list 3, 4 and 5. And let me get out of this loop, and now you can see print the list method is executed, and 1 2 3 4 5 is getting printed. And after that length method called, and now the length of the list is 5. And now we came here at the line number 82 and enter the data to insert at the first. And now if I trying to insert 10 in the list, and if I hit enter, now you can see print list method is called. The list is now 10 1 2 3 4 5, which is before 1 2 3 4 5, and now it is 10, which is added at the beginning. And the length of the list is also incremented by 1, we have, because we have 6 elements inside the list. So this is how we can create a method to insert a node at the beginning of the circular linked list. So in our upcoming videos, we will see how we can insert a node at the end of the circular linked list, or at the user specified position inside a circular linked list. So thank you for watching this video, and I will see you in the next one. So hello and welcome back to the new video of the Java tutorial series. So today in this video we will be seeing how we can insert a node inside a circular linked list at the end. Okay, so we are trying to insert the node inside a circular linked list at the end. Okay, so imagine this is our circular linked list, which contains four node. Okay, and now we are trying to insert this fifth node inside the circular linked list, which is at the end. Okay, so for circular linked list, we have tail dot next as a head. So if we are trying to insert this node inside the list, what are all modifications that we have to do? Let's talk them first. Okay, so the first thing we have to do is we have to change the tail dot next value. So currently it is pointing to the head of the list, that is the first node of the list. So instead of pointing to the head of the list, it should point to the new node, because now if we insert this node at the end, this will not the node which will at the end. Okay, so our last node will get updated. So we have to assign the tail dot next value to the new node. Okay, so after doing that, we can now update the tails value. So we will make the tail to point towards this new node. Okay, so our tail is also shifted by one position to the end. And now we can go ahead and simply write tail dot next is equal to head. Okay, so we are breaking the bond which is created at the tail dot next is equal to head first, by assigning the tail dot next value to the new node. And after that we will changing the tails value to the new node. So the tail should point to the last node of the list, which is our new node. Okay, and after that, after doing all this, we can just simply write new node dot next, or else tail dot next is equals to head. now, so to maintain the circular motion inside our circular linked list. Okay, so these are the three things that we have to do in order to insert a node at the end of the circular linked list. Okay, so let's go inside our IDE and see how we can implement this. Okay, and I will come here and I will just write our comment so that we can know what's happening inside that method, right? So we'll write insert at the end. Okay, so we are trying to insert the node at the end. Okay, so we'll write public method should be static, and we are trying to insert a node, so we are updating our list, so it should return the new node obviously. And after that we'll write insert at end, and this method should take the head of the list so that we can modify the list or insert the new node at the end of the list. Okay, so first thing first, we will ask the user to enter the data. So let me just copy this line from the previous video where we are trying to insert the node at the first. Now we are trying to insert the node at the end. Okay, and I will just write int data is equals to sc dot next int. Okay, and after that now I can create my node which is of type node c. I will name it as new node c, which is equals to the new node c, and we'll pass the data. Okay, after that we have to check one corner case, that is if my head is equals to null, that means there is no node inside the list which are present. And in that case we will just simply write new node head is equal to new node c, and we will write tail is also pointing to the new node c because that will be the first node inside the list. Okay, okay, sorry, my bad. If my head is equals to null, then in that case we will just simply write head equals to new node c. Okay, and inside my if condition I will write this like this. Okay, it's fine now. If my head equals to null. Okay, then in that case we will just simply write head is equal to new node c, tail is equal to new node c, and we will write new node c dot next should point to the head. Okay, so after doing that, if that is not the case, then we come inside this else part where we know we have some nodes present inside our list, and we have to insert the new node at the end of the list. So we will write tail dot next should point to the new node as we have discussed. Okay, and after that we will write tail is equals to new node c, and after that we will write tail dot next should point to the head of the list, and after that we will just simply return our head of the list. Okay, so this is pretty much we have to do inside insert at the end. Okay, so I will just comment out this previous code where we are trying to insert the node at the beginning. So I will just comment out, and below that we will write node c. Since the method is returning a new node of the list, so we have to capture that inside our main method. So we will write new node new on instead of writing new node we just write new head. Okay, and I will call that insert at end. Okay, and we will pass the head that we are getting from the line number 95, and below that we will write the print list method and we will pass the new head. Okay, okay, and after that we just find the length of the list by giving the new head of the list. Okay, so now if I go ahead and run this code, I should first okay, so give the list 1 2 3 4 5. I will write -1, So you can see for the previous list we have 1 2 3 4 5, and the length of the list is also 5. And now it is asking for the data which is to be inserted at the end. I will write 10 to be inserted at the end, and after that you can see 1 2 3 4 5, and 10 is inserted at the end position, and the length of the list is also incremented by 1 because now there are 6 elements inside the list present. Okay, so this is how you can implement the code to insert a node inside the circular linked list at the end. So in our upcoming video, we will see how we can insert a node inside the circular linked list at the user specified position. Okay. Thank you for watching this video, and I will see you in the next one.